The Mariana Trench has already swallowed more secrets than the human mind can hold. And tonight, we are going down into it. You are listening to Depth Unseen. Where light ends, the story begins. Tonight we go somewhere most humans will never go. Settle in. Close your eyes. Drift with us. The Mariana Trench. Say it slowly. Let the words sit in your mouth like cold water. Mariana Trench. There is something about that name that already feels like a warning. Like the name of a place that was never meant to be found. And yet, here we are. Here you are. Leaning toward it. Curious about the thing that lives in the dark at the very bottom of the deepest place on this entire planet. Something does live there. That is the part that stops people. That is the part that makes scientists put down their coffee and stare at the data, again and again, not quite believing it. Life. Actual breathing, moving, feeding life. Proud. Down. In a place where the darkness has never once been interrupted by sunlight. Down, where the pressure of the water above would crush a steel submarine like a paper cup. Down at the very bottom of the Mariana Trench, something is alive. Something has always been alive. And most of it, we have never seen. Let that sit with you for just a moment. We have sent spacecraft to Mars. We have photographed the rings of Saturn from billions of miles away. We have mapped the surface of the moon with more detail than your own neighbourhood. But the bottom of the Mariana Trench, right here on our own planet, in our own ocean, remains mostly unknown. More unknown than the surface of the moon. More mysterious than the far side of Jupiter. The deepest point of the Mariana Trench, a place called Challenger Deep, sits nearly 7 miles below the surface of the Pacific Ocean. 7 miles? If you drop Mount Everest into the Mariana Trench, peak would still be more than a mile underwater. And down there in that crushing, freezing, lightless place, life found a way. Tonight, we are going to find out exactly what that life looks like. We are going to descend slowly, layer by layer, into the Mariana Trench. We are going to meet the creatures that call this impossible place home. But here is the thing about descending into the Mariana Trench. Cannot rush it. The ocean will not let you rush it. To reach the bottom, even in the fastest submersible ever built, takes hours. Those hours matter. Because the deeper you go, the stranger the world becomes. The rules change. The physics bends. The biology does things that should not be possible. So, we will take our time. We will go slowly. We will let the dark come to us. Close your eyes, if you would like. Let your body become heavy. Let the weight of the world above you press you gently downward, because that is exactly how it begins. The Pacific Ocean is the largest body of water on Earth, covers more than 1/3 of the entire surface of the planet. If you took every continent and pressed them together, they would still not fill the Pacific. It is so wide that on one side the sun is rising, and on the other side it has already set. It is so deep in places that light from the surface fades to nothing, before it even travels a fraction of the way to the bottom. Pacific is not just an ocean. It is a world inside our world. A second planet that we have been living next to since the very beginning of human history without ever truly understanding it. And at the western edge of the Pacific, somewhere between Japan and the island of Guam, ocean floor drops away. It does not slope gently. It does not fade gradually into deeper water. It drops, like a trapdoor opening beneath your feet. Like the earth simply decided to stop holding itself up. The seafloor falls away in a steep dramatic plunge and forms what scientists call a subduction zone. That is a place where one giant plate of rock that makes up the Earth's crust slides underneath another. It grinds and pushes, and over millions and millions of years the seafloor gets pulled down and down and down until it becomes the deepest scar on the surface of the planet, the Mariana Trench. It stretches for about 1,580 miles. That is longer than the entire state of California, laid end to end 5 times over. It is a crescent-shaped wound in the floor of the Pacific, narrow and impossibly deep, and it is as old as memory itself, older. The rocks at the bottom of the Mariana Trench have been sitting there for nearly 180 million years. When those rocks were young, dinosaurs had not yet appeared on land. World above was so different it would feel like a different planet. And yet that trench has been there. Quiet, dark, waiting. Now here is something that will stay with you. Every single year, the Mariana Trench gets very slightly deeper. Almost too small to measure, just a few millimeters. But it is moving. The plates are still grinding. The Earth is still pulling the ocean floor downward, inch by inch, century by century. The Mariana Trench is not a fixed thing. It is alive in its own slow geological way. A wound that never closes, mouth that never stops opening. We are going down into that mouth tonight. First thing you lose when you descend into the Mariana Trench is the colour red. That might seem like a strange thing to say, but it matters. Light travels through water in layers. Akos. The moment you drop below the surface, the long wavelengths of light begin to disappear. Red goes first, then orange, then yellow. By the time you are a few hundred feet below the surface, the world around you is only blue and green. It is still beautiful. It is still lit. But red is gone. Flowers dropped into this water would look grey. Blood would look black. The world has already started to change. By about 600 feet down, the light begins to dim in a way that feels like twilight. Not dark yet. The sun feels far away. The warmth is gone. The water temperature has dropped to levels that would numb your hands in minutes. Here in this zone, called the twilight zone by scientists, the creatures begin to get strange. They grow their own lights, tiny glowing spots along their sides, bellies, their faces. This is called bioluminescence, and it is one of the most extraordinary facts about the deep ocean. More than 75% of all deep-sea creatures make their own light. Think about that. 3 out of every 4 animals in the deep ocean carries its own lantern. Oh. Thus, not because it is bright or warm down there, but because in total darkness, light becomes a language, a signal, a lure, a warning, a weapon, and we have barely started sinking. Below the twilight zone, the last trace of sunlight disappears entirely. This is called the midnight zone, and it begins at about 3,000 feet below the surface. Here the darkness is not like the darkness of a room with the lights off. It is not like a moonless night. It is a darkness so complete and so absolute that it has its own quality to it. A thickness, a weight. Scientists who have gone to these depths describe it as a darkness you can feel. Darkness that presses against you from all sides. As if the night itself has become solid. Pressure at 3,000 feet is about 90 times greater than the pressure at sea level. 90 times. Imagine taking the entire weight of the atmosphere above you and multiplying it by 90. Your lungs, your chest, the spaces inside your skull, Everything that holds air would collapse in an instant without protection. The creatures that live here have no air spaces inside them at all, no swim bladders filled with gas, no air pockets, no hollow bones. They are dense and fluid all the way through, built by millions of years of evolution to match the pressure perfectly, so the crushing weight of the water does not destroy them. They are the ocean, made solid. They are pressure given a shape. But the Mariana Trench goes so much deeper than this. We have not even reached the edge of the trench yet. We are still in the open ocean, still in the upper zones, still far above the place where the real story begins. Below 3,000 feet is another world. Below 6,000 feet is another world, still. Below 10,000 feet. Below 20,000 feet. Below 30,000 feet, the Mariana Trench opens. Like a secret that the planet has been keeping since before humanity existed. Here is what you need to understand about the Mariana Trench before we go any further. It is not a crack in the ocean floor. It is not a simple ditch. It is a canyon, so vast and so complex that scientists who have spent their entire careers studying it still argue about its exact shape. It has walls that rise thousands of feet above its floor. It has valleys within valleys. It has plains and ridges and peaks that no human eye has ever seen clearly. It is its own entire geography, its own complete world, hidden at the bottom of another world. When people say the Mariana Trench, they are really naming an entire realm, varied and dramatic as any mountain range on land, but hidden under 7 miles of water and darkness. The deepest point of this realm, very lowest place on Earth, is called Challenger Deep. The name comes from HMS Challenger, British naval ship, that first measured extraordinary depths in this region. Back in 1875, the sailors on that ship were lowering ropes, weighted with metal, to measure the ocean's depth. When they checked their measurements, they could not believe what the numbers said. They measured a depth of over 4 miles in that location. They were the first humans to suspect that the Mariana Trench existed. They had no idea what they had found. They could not imagine what was down there. They wrote migrant. They wrote their measurements carefully in their logs and sailed on, carrying the first hint of this discovery back to a world that was not ready for it. Challenger Deep. Remember that name. We will come back to it. For now, let us keep descending. Let us keep sinking deeper into the Mariana Trench. Let your breathing slow a little. Let the story carry you down. Water is cold here. Not just cool. Not just chilly, or cold that comes from being so far from warmth for so long that it has become the natural state of things. The temperature near the bottom of the Mariana Trench hovers just above freezing, just barely, a few degrees above the point at which water turns to ice. You would not survive in this water for even a minute without protection. Your body would go into shock. Your heart would stop. The cold would take you before the pressure ever got a chance. And yet things live here, warm-blooded in their own way, or cold-blooded and perfectly adapted. It makes no difference to them. They do not notice the cold. It is just home, now. Here is the question that pulls you forward tonight. Here is the question that has kept scientists awake and arguing, and sending incredibly expensive submersibles down into the dark for over 100 years. What exactly lives at the bottom of the Mariana Trench? Not just what lives in the deep ocean, not just what lives below the light, But what lives at the very deepest point, the very bottom of Challenger, deep, where the pressure reaches 8 tons per square inch, and the darkness has never once been broken by anything except the lights carried by the scientists and explorers brave enough to go there. 8 tons per square inch. Let us think about what that actually means, because it is easy to say a number and not feel it. Imagine 1,000 of the largest elephants you have ever seen all standing on a dinner plate at the same time. That is roughly the kind of force we are talking about, pressing against every single inch of your body. A force that would not just hurt you, force that would compress you instantly into something unrecognizable. The body at that pressure does not crush slowly. It is simply absorbed, consumed, erased by the weight of all that water above. And yet something survives it. Something thrives in it. Something has been living there for millions of years in the dark, at the bottom of the Mariana Trench, eating and reproducing and evolving, completely indifferent to the fact that a world full of light and warmth and colour exists 7 miles above its head. Creatures are waiting for us. But we have to earn them. We have to go slowly. We have to descend in layers, because the Mariana Trench is not just a single place. It is a series of worlds stacked on top of each other, each one stranger than the last, each one darker, each one colder, each one more extreme. And if we skip ahead, we will miss the story. We will miss the slow transformation. We will miss the way the ocean changes you as you sink deeper into it. So, let us begin our descent properly. The surface of the Pacific Ocean, where the Mariana Trench begins its downward plunge, is deceptively ordinary. If you were floating there on a raft, you might not even know anything was unusual below you. The water is blue and bright and moves in gentle swells. Schools of flying fish break the surface. Seabirds wheel above you in the wind. The sun is warm. The world feels generous and alive and open in all directions. Nothing about the surface suggests what is happening 7 miles beneath your feet, but beneath that beautiful ordinary surface, the ocean floor is already beginning to slope, already beginning to angle downward. At about 100 miles to the west, the slope accelerates, it tips, it falls, and the Mariana Trench begins. First zone of the trench is called the epipelagic zone, which means the sunlit zone. This is the top layer, the first 600 feet or so, where light still reaches from the surface. This is where the majority of ocean life lives, where dolphins play and turtles swim and sharks hunt, where coral grows in places shallow enough to be touched by both sun and sea. This world is alive and bright and loud in its own underwater way, the click of shrimp. The song of whales carried impossibly far through the water, the rustle of kelp in the current. This upper world is the ocean. Most of us know the one we imagine when someone says the word ocean. But we are going deeper than this. The next zone is the mesopelagic zone, the twilight zone. Here, between about 600 and 3,000 feet, the light fades gradually from dim blue to nothing. This is where the ocean begins to make its own light. Here in this fading world, creatures like the lanternfish and the hatchetfish swim in their millions. The lanternfish is one of the most common vertebrates, meaning animals with spines, on the entire planet. There are so many of them in the ocean that when ships dropped sonar signals into the water, the mass of lanternfish reflected the sound back up and appeared on screens as a second false ocean floor. scientists for years thought there was a mysterious layer at 2,000 feet that the sonar could not penetrate. It was fish, millions upon millions of tiny glowing fish, so dense they looked like solid ground. That is the kind of thing the deep ocean does to you. It makes you doubt what is real. It makes you question what you think you see. We go deeper, still, the bathypelagic zone, the midnight zone, 3,000 feet to 13,000 feet. Here the sun is truly gone. Not dim, not fading, gone. This is permanent night. The creatures here are nightmares made beautiful by millions of years of evolution. The fang-toothed fish, which has the longest teeth relative to body size of any fish in the ocean. Its teeth are so long it cannot even close its mouth all the way, swims through permanent darkness with its jaws slightly open, always ready, always hunting. Because down here food is rare, and when it comes, cannot afford to miss it. The dragonfish, which has a long barbel, a thin filament hanging from its chin with a glowing light at the end, a living fishing rod, dangling a lantern in the dark to lure curious prey close enough to catch. The anglerfish, females carry a bioluminescent lure attached to a spine growing from their own forehead. A light in the dark that says, "Come here, come closer, do not worry. Everything is fine." It is not fine. But everything in the deep ocean is alive in ways that rewrite our understanding of what life can be. These are not simple primitive creatures, they are masterworks of adaptation. They are solutions to problems that sound impossible. How do you hunt in total darkness? How do you find a mate when the ocean is so vast and so black that another member of your own species might be a mile away in any direction? How do you survive when food only falls from above at random intervals, and sometimes days or weeks pass with nothing at all? The deep ocean answered every one of those questions. With light, with patience, with bodies that are more water than flesh, strategies so elegant and strange they look like magic, and still, we are not at the bottom of the Mariana Trench. Below the midnight zone lies the abyssopelagic zone. The abyss zone, 13,000 to 20,000 feet. Here, the pressure becomes something almost religious in its intensity. The weight of the ocean is not something you can calculate, and then understand intellectually. It is something you have to feel to know what it means. And the only humans who have felt even a fraction of it are the ones who have climbed into small metal spheres and trusted those spheres with their lives, and descended into a darkness that has no bottom for hours at a time. In the abyss zone, the seafloor spreads out in vast plains of soft sediment. Fine particles of organic matter, the remains of dead plankton and fish, and everything that dies in the ocean above sinks slowly for years before coming to rest here. This sediment is called marine snow, and it falls in an endless soft drift downward through the dark. Marine snow. Think about that image. Snow that never stops falling, that has been falling for millions of years. That is the only food source for many of the creatures that live in the deepest parts of the ocean. Every fragment of dead matter that sinks from the surface is a meal for something in the dark below. Nothing is wasted. Everything is eaten. Everything becomes something else. The creatures of the abyss zone are designed for scarcity, for waiting, for eating anything that comes. Sea cucumbers. Those strange soft animals that look like oversized pickles slowly across the sediment floor in massive numbers, in some areas of the abyss. They vacuum the sediment, eating the marine snow that has collected in it, extracting whatever nutrition exists in the thick, soft mud. They are not dramatic, they are not fast, but they are extraordinarily successful. Sea cucumbers make up more than 90% of the total body weight of all animals living at the deepest levels of the ocean. 90%. In the deepest places on Earth, the dominant animal is a slow-moving soft tube that eats mud. Life found its own logic down here, and that logic is nothing like ours. And still, we have not reached the Mariana Trench's own private territory. Still, we have not entered the zone that belongs only to the trenches, only to those steep-sided canyons that plunge below everything else, below even the vast plains of the abyss. That zone has a name. It is called the Hadal Zone, and the name comes from Hades, Greek god of the underworld, the realm of the dead. It was not named carelessly. The Hadal Zone begins at about 20,000 feet and extends to the very bottom of the deepest trenches on Earth, very bottom of the Mariana Trench. This is a world so extreme that for a long time many scientists believed it was simply incompatible with life. Pressure alone, the thought of it, seemed to make biological existence impossible. Proteins, the building blocks of every living cell, delicate structures. They fold into specific shapes, and those shapes are what allow them to function. When pressure reaches certain levels, proteins get distorted. They unfold. They stop working. If proteins stop working, cells stop working. If cells stop working, life stops. But life did not stop. Life does not stop. Here is what the ocean taught us. Deep-sea creatures in the Hadal Zone produce a molecule called TMAO, trimethylamine oxide. It is a chemical that exists inside the cells of deep-sea fish and crustaceans and acts as a kind of pressure equalizer, keeps proteins from being destroyed by the crushing weight of the water. The deeper you find a fish in the Hadal Zone, the more TMAO it has in its tissues. More TMAO, more protection from pressure. It is as if evolution handed these creatures a molecular shield, an invisible armour built from chemistry rather than bone. Scientists studying this molecule believe it could one day be used in human medicine, in ways that help preserve organs for transplant or protect cells during surgery. The secrets at the bottom of the Mariana Trench are not just wonders. They may be medicines, they may be cures, but you are wondering about the bottom itself. You are wondering what lives at the very lowest point, breathes and eats, and moves in Challenger deep, where the pressure is 8 tons per square inch, and the darkness is absolute and the cold is just barely above freezing. We are almost there. The descent takes time. Settled deeper. Let the story take you down. The Mariana snailfish. This is the creature that stopped scientists. This is the animal that changed everything. Scientists thought they knew about the limits of life. Found first in 2014 and fully documented by 2017. The Mariana snailfish holds a record that still stands today. It is the deepest living fish ever recorded on Earth. Found at over 26,000 feet below the surface, 8,000 meters down. Alive, swimming, feeding, not struggling, not suffering, thriving. It does not look like what you might expect from the champion of the deep. It is not armoured or terrifying. It is not jagged-toothed or monstrous. The Mariana snailfish is small, about a foot long, pale pink and almost translucent. If you held one up to the light, you could see its organs through its skin, ghostly silhouette of everything inside it. It has no scales. Its skeleton is mostly cartilage, not hard bone, because hard calcium-based bone cannot exist at those pressures. The pressure itself would dissolve it, so the snailfish is soft, flexible, bends instead of breaking. It moves in gentle undulating motions through water so cold and so dark that its entire world is defined by the faint chemical traces of food and the vibrations of movement it can detect through its sensory organs. Clusters with others of its kind near the seafloor, swimming in loose groups, feeding on tiny crustaceans that crawl through the sediment. It is social in its own quiet way. It is not alone down there, and something about that is deeply comforting and deeply unsettling at the same time, because the Mariana snailfish did not evolve in isolation. It is part of a community, part of an ecosystem. There are things it eats, and things that may eat, and things that may eat it or compete with it for food. Fact that one species can survive at those depths means that a network of life exists around it, web of feeding and dying and decomposing and being reborn into something else. The Mariana Trench is not a cemetery. It is not a wasteland. It is a functioning, ancient, complex ecosystem that has been operating continuously for millions of years without any awareness of the world above it, without any awareness of us. How long has the Mariana snailfish been down there? How many generations have lived and died in Challenger Deep? Without ever knowing that 7 miles above them, species of curious warm-blooded primates was inventing language and fire, and eventually submarines to come looking for them. Millions of years, tens of millions, perhaps. The ancestors of the snailfish made this choice, if evolution can be called a choice, long before humans existed. They went deeper and deeper and stayed. And now they are here, permanent residents of the deepest place on Earth, perfectly shaped by time and pressure into something extraordinary. But the snailfish is not the only one. And here is where the story gets stranger. Here is where you need to let go of everything you think you know about what life looks like. At the bottom of the Mariana Trench, crawling through the sediment, fluttering slowly through the water, pressed flat against the seafloor, creatures that seem to belong to another world entirely. Entirely. Some of them are so alien in their appearance that the scientists who first filmed them spent hours arguing about what they were even looking at. And some of them are so simple, so ancient, fundamental, that they are more closely related to the very first life on Earth than they are to anything alive today. We will meet them in the next part of this journey. But for now, let this sit with you. Let the weight of it press against you the way the ocean presses against everything in the Mariana Trench. Life is not fragile. That is the lie we were taught quietly, without meaning to teach it. We were taught that life needs warmth and light and gentleness to survive, that without the sun and the air and the comfort of moderate temperatures, and existence becomes impossible. The Mariana Trench looked at that idea and decided otherwise. The Mariana Trench said, "Give me your darkest place, give me your coldest water, give me pressure that would crush steel and temperature, that would freeze flesh and darkness, that has never once been broken by sunlight in the entire history of the planet. And something will live there. Something will always live there. Because life, it turns out, does not need the conditions we thought it needed. Life needs almost nothing except chemistry. The right molecules, the right reactions, right sequence of events stretching back through billions of years of trial and error and death and adaptation. And when those conditions are met, even at the bottom of the deepest trench, in the deepest ocean, on the most water-covered planet in the known universe, life will find its way. Creatures at the bottom of the Mariana Trench are not surviving, despite their environment. They are thriving because of it. Pressure that would kill us is the pressure that keeps them alive. The cold that would stop our hearts is the cold that slows their metabolism, makes their food last longer. The darkness that terrifies us is the darkness that hides them from predators and makes their own light, their own bioluminescent glow, visible across vast distances in a way it never could be under a sun. They did not lose their world, built a different one. And 7 miles above them, we are only just beginning to find it. First humans to ever reach the bottom of Challenger Deep were 2 men named Don Walsh and Jacques Piccard. It was January 23rd, 1960. The Cold War was at its height. The space race was already underway. Humans were pointing themselves at the stars, while these 2 men pointed themselves in the exact opposite direction. Down. Their vessel was called the Tristest, a bathyscaphe, which means a kind of deep-diving vessel. It was nothing like a modern submarine. It was a thick-walled steel sphere attached to a massive float filled with gasoline, not air. Gasoline, because gasoline is less compressible than water, which means it would not be crushed at depth. The vessel looked less like a spacecraft and more like a buoy attached to a flying saucer. It was not graceful, but it worked. The descent to the bottom of the Mariana Trench took 4 hours and 48 minutes. 4 hours and 48 minutes of sinking through absolute darkness, in a cramped sphere of listening to the sounds of the metal hull adjusting to the increasing pressure, pings and groans and creaks of steel being tested by forces it was never quite designed for. One point, during the descent, a plexiglass viewing window cracked, and the sound was so loud it shook the entire vessel. Walsh and Piccard did not know if the crack would spread. If it would shatter completely, the ocean would suddenly pour in, and that would be the end. They continued anyway. They reached the bottom of the Mariana Trench at 814 feet below the surface. The pressure outside their hull was 8 tons per square inch. They spent 20 minutes at the bottom. 20 minutes for post. In those 20 minutes, the floodlight of the Trieste illuminated something in the sediment below them, something flat and pale, something that moved. Piccard believed it was a flatfish. He was so excited he could barely write the words in his log. A fish. An actual fish, bottom of the deepest place on Earth. He wrote later that it was one of the most moving moments of his life. Once. Not because he had reached the bottom of the Mariana Trench, though that alone was extraordinary, because of what that small, pale creature in the sediment represented. It meant the Mariana Trench was not a dead place, was not a lifeless abyss. It was a neighbourhood, a dark, cold, crushing neighbourhood, but a neighbourhood all the same. Whether what Piccard saw was truly a fish is still debated today. Some scientists think it may have been a sea cucumber. The lighting was poor, the observation brief, the conditions extraordinary. But The possibility that even a fish, with its bones and its swim bladder and its fragile biology, might have been alive and resting on the floor of Challenger Deep still stirs something in every person who hears about it. Because if that is true, if a fish can exist at the very bottom of the Mariana Trench, then the universe of life on this planet is even wider and more astonishing than we dared to believe. It is now time to go a little deeper into what science has actually confirmed. What has been seen? What has been filmed and caught and analysed and measured? What the cameras and the submarines and the drop traps and the sediment samplers have brought back from the bottom of the Mariana Trench over the past 60 years. Because Pickard and Walsh were only the beginning, after them came others. Scientists who built better tools, instruments that could withstand the pressure, cameras that could function in the cold, traps that could descend to the deepest point of the Mariana Trench, and come back up again with what lived there preserved and ready for study. What they found was not nothing. It was never nothing. In the sediment at the bottom of the Mariana Trench, scientists discovered bacteria. Not a few bacteria, not a scattering. Bacteria in extraordinary numbers. More bacteria per square centimetre than you would find in many surface ocean environments. These were bacteria of a specific kind called heterotrophs, organisms that cannot make their own food but must consume organic matter to survive. They were feeding on the marine snow, on the particles of dead organic matter that had been raining down for millions of years through 7 miles of water to settle on the floor of Challenger Deep. These bacteria were alive, active, busy. They were doing exactly what bacteria have been doing for 3.5 billion years on the planet. They were eating. They were dividing. They were filling every available space with more of themselves. Okay, and bacteria are not glamorous. They are not the creatures of science fiction nightmares or nature documentaries. They do not have fins or eyes or glowing lights, but they are the foundation of everything. They were the first life on Earth. They have survived every mass extinction, every ice age, asteroid impact, every catastrophic eruption that has ever shaken this planet. They were alive before animals were invented. They will be alive long after animals are gone. And they are alive right now, at this very moment, at the bottom of the Mariana Trench, the deepest darkness on Earth, going about their ancient business completely undisturbed. That is what it means to be fundamental to life. That is what it means to be truly indestructible. But there is something even stranger below the bacteria, something that blurs the line between living and not living. Something that was discovered in the deepest sediments of the Mariana Trench and left scientists arguing for years about how to categorize it. Something that has been called the simplest possible form of life. And if we are going to understand what lives at the very bottom of the Mariana Trench, we have to talk about it. Something is called a xenophyophore, and the name alone sounds like something out of a dream or a nightmare, depending on which way your imagination bends. A xenophyophore is a single-celled organism. Just one cell. One. But here is the thing that makes it extraordinary and strange and almost impossible to believe. Some xenophyophores are among the largest single cells in the world. One species found in the Mariana Trench, captured on camera at a depth of over 34,000 feet, is approximately 4 inches long. 4 inches. One cell, 4 inches across. Think about what a cell is. In your own body, a single cell is so small that thousands of them could fit on the head of a pin. A single cell is invisible. A single cell is a microscopic speck of chemistry and water, enclosed in a membrane so thin that the concept of thinness barely covers it. And yet here, at the bottom of the Mariana Trench, a single cell can grow to the size of a mango. A single cell that you could pick up with your hand if your hand could survive the pressure. A single cell that moves and feeds and reproduces in the deepest part of the ocean. In the dark, in the cold, crushing weight of 8 tons per square inch. If you held a xenophyophore in your hand, you would be holding one living cell. One, and you would hold it gently. Because you would know that, of whatever you thought you knew about size and complexity and the relationship between the two, the Mariana Trench just quietly rewrote it. There is so much more to tell. The night is long, and the Mariana Trench goes deeper than words can easily follow. But we are making our way. We are descending slowly, as the ocean demands, not rushing, not skipping, letting the full weight of this place become real in your mind and your body, and the way you breathe. In the next part of this journey, we will go deeper still into the Hadal zone. We will meet the amphipods, shrimp-like creatures, like creatures that swarm at the bottom of the Mariana Trench in numbers that shock everyone who first hears about them. We will meet the dumbo octopus, the most elegant creature in the deepest dark. We will follow the trail of marine snow from the surface all the way to the floor and understand the full cycle of life and death that feeds everything in the abyss. We will talk about the moment scientists first caught living creatures from Challenger Deep and brought them up to the light, and we will begin to ask the question that nobody has answered yet. The question that keeps the lights on in research labs around the world. Question that drives submersibles back down into the dark again and again year after year. Is there something in the Mariana Trench we have still not found? Something larger, stranger, older, more complex than anything we have imagined. The ocean floor of Challenger Deep has been directly observed by human eyes for a total of fewer than 5 hours in all of human history. Everything else we know came from cameras and sensors and samples pulled up from the dark on the end of a wire. We have seen almost nothing. We have understood even less. And the Mariana Trench is patient. It has been waiting for 7 miles of questions to be asked, for 7 miles of darkness to be travelled by light, for 7 miles of pressure to be met by curiosity. Mariana Trench creatures do not simply endure the bottom of the world. They gather there in numbers so strange that the first cameras to see them made scientists question what hunger looks like in the dark. You are listening to Depth Unseen. Where light ends, the story begins. Tonight, we go somewhere most humans will never go. Settle in, close your eyes, and drift with us. Mariana Trench has now carried us past the familiar edge of imagination. We are below weather, below waves, below every place where sunlight has ever touched. We are inside the Hadal zone now, the trench world, the underworld of the ocean, the place named for ancient darkness. And here, at depths, where the weight of the Pacific presses down, with a force almost too large for language, seafloor is not. It's empty. It is moving, not quickly, not loudly, not in any way that would remind you of the life of the surface. Nothing darts here in bright schools, nothing splashes, nothing breaks the silence. But The bottom of the Mariana Trench is not still. It is busy with slow mouths, patient bodies, soft limbs, tiny legs, invisible microbes, and the constant, ghostly fall of food from the world above. This is the first truth many people never hear. The deepest place on Earth is not dead. It is fed. It is inhabited. It is part of a chain of life, so long and so delicate that a dead leaf of algae drifting down from the sunlit sea may, months or years of sinkings, end up inside the body of something living at the bottom of Challenger Deep. And that means the bottom is connected to the surface in a way that feels almost like myth. A whale dies near the surface. Its body sinks. Fish strip at it on the way down. Flesh loosens, fat breaks apart, bones descend, smaller scavengers gather, bacteria bloom. The sinking body becomes a feast falling through layers of dark, and by the time pieces of it reach the Haddle floor, Mariana Trench receives them like offerings from a distant sky. Nothing down here wastes that gift. Nothing can afford to. This is one of the great rules of the deep trench world. Energy is rare, food is unpredictable. When something edible appears, the bottom comes alive. And if that sentence sounds calm, do not trust the calm completely. Because one of the most astonishing things ever filmed in the Mariana Trench was a giant predator, or some impossible monster gliding through black water. It was a swarm, a sudden gathering, hundreds of small, pale bodies converging on bait lowered into the trench, arriving out of darkness, with such speed and such certainty that it became clear they had been there all along. Waiting beyond the reach of light, hidden a blackness so complete that they seemed to materialize from nothing. These creatures are amphipods. The word may sound technical, but the animal itself can be explained simply. An amphipod is a small crustacean, a relative of shrimp, crab, and lobster. Many amphipods in shallower water are tiny. Some live in seaweed, some hop through beach wrack, but in the deep trenches, amphipods become something else. They become the scavengers of the underworld. They are pale, translucent in places, bent like commas, armoured just enough to move through abrasive mud and pressure-filled water. Their legs work constantly. Their antennae taste the water. They detect chemicals released by decay with extraordinary sensitivity. If food appears in the Hadal's zone, amphipods know 'tis. That is the second truth of the Mariana Trench. The dark is not empty between meals. The dark is listening. Imagine a lander descending, simple machine. A frame with cameras, lights, instruments, and bait attached, lowered mile after mile into the trench, falls through darkness for hours. It lands softly on the sediment. The lights flare outward, weak and artificial, making a small white island in an endless black plain. At first, there is nothing. Just the fine dust of disturbed sediment slowly settling, then one shape, then 3, then 20, then too many to count cleanly. Amphipods arrive from every direction, drawn by the faint invisible stream of chemicals spreading from the bait. They clamber over each other. They cover the offering. They feed with a kind of silent urgency that feels almost ceremonial. And what strikes scientists every time is not just that they are there, it is how many are there. So many lives hidden in a place once believed nearly barren. The amphipods of the Mariana Trench are not all the same. Some are small and delicate. Some are larger, thick-bodied, almost startling in size compared with the shallow water forms people are used to. One species associated with trench depths, Hirondelia gigas, has become one of the best known haddle scavengers in the world. It is not famous because it is frightening. It is famous because it works. Its whole body is a solution. It survives pressure that destroys other crustaceans. It feeds on plant material, and carrion reaching the trench floor processes what falls from above. It turns death into motion. And here is the part that feels almost impossible the first time you hear it. Some haddle amphipods have been found with aluminum in their bodies, apparently extracted from the sediment around them, and used in ways that may help protect them from the pressure. Aluminum is not something we think of as a living material. It belongs in cans, aircraft, ladders, window frames, yet down here chemistry is rewritten. The trench takes elements from rock and mud and folds them into the business of survival. Biology and geology stop feeling separate. They begin to blur. That blurring happens again and again in the Mariana Trench. The sediment itself is not simple dirt. It is history ground fine. Volcanic ash, mineral dust, fragments of shell, microscopic skeletons of plankton, bits of dead animals, bits of old currents, bits of vanished seasons. Everything that has ever drifted down and stayed becomes part of the haddle floor. When an amphipod digs into that sediment, it is digging into a library of falling time. When a sea cucumber swallows a mouthful of mud, it is swallowing years. When bacteria divide in those grains, they are turning memory into energy. And this is why marine snow matters so much. Marine snow is a gentle name for something enormous. It is the constant shower of organic material sinking from upper waters. Dead plankton, waste pellets, mucus threads, scales, eggs, scraps, dust of life. It drifts down through the water column in slow spirals and soft flakes. Because the ocean is so deep, most of it is eaten before it reaches the bottom. Countless mouths intercept it along the way. Tiny feeders in the twilight zone, hunters in the midnight zone, jellies, worms, crustaceans, bacteria. The ocean recycles almost everything before it can finish its fall, which means that what finally reaches the bottom of the Mariana Trench is only a small fraction of what began the journey. And yet even that small fraction is enough to support an ecosystem. That is the miracle hidden in plain 9 science. Not abundance, efficiency, not plenty, persistence. Bottom of the Mariana Trench runs on leftovers from another world, and it has learned to do astonishing things with them. Now, imagine the seafloor again. Not as a bare plain, but as a place of faint textures and small movements. The mud is softer than beach sand, finer than flour in some places. If you touched it, it would bloom upward in clouds. Delicate tracks cross it, tiny trenches made by crawling bodies, light depressions where something settled. Narrow trails where an animal fed and moved on. Every mark is a sentence in a language of passing hunger. Among the readers of that language are the sea cucumbers. Sea cucumbers do not sound majestic. Their name does them no favours. It sounds almost comic, almost too harmless for the deepest place on Earth. But look more carefully. A sea cucumber is a muscular tube with feeding tentacles, and a body built to process sediment with astonishing patience. In the Haddle Zone, certain sea cucumbers become some of the most important large animals on the seafloor. They move slowly. Yes. They look soft. Yes. but softness is a strength here. Hard parts can fail, brittle structures can snap. A yielding body can survive. Some Haddle sea cucumbers have translucent skin so thin that light from a submersible can reveal the dark mass of sediment inside them. Some drag themselves over the mud like living bellows, inhaling the seafloor and exhaling it, altered, stripped of every edible trace. Some lift their feeding parts into the water of the bottom just above the bottom, tasting suspended particles before letting them settle. They are not elegant in the surface world sense, but in the trench, they are perfectly suited to the task. They are processors, recyclers, custodians of the underworld floor. And sometimes, in footage from the deep, they appear in such numbers that the sediment seems to have sprouted pale, moving fruit. This is where the Mariana Trench begins to feel less like a void and more like a hidden countryside. Slow grazers on open plains, scavengers arriving in clusters, tiny hunters weaving between grains, microbial cities invisible to the eye, all of it powered by the long weather of falling matter. But there is another creature waiting here, one that people love the moment they see it, even though it lives in one of the harshest places on Earth. The dumbo octopus. Its nickname comes from the two fin-like flaps on either side of its head, which resemble ears when it swims. It moves with a soft, pulsing grace, opening and closing its webbed arms beneath its body like a small, floating cloak. In the deep sea, where so much life looks armoured, jagged, or severe, the dumbo octopus seems almost gentle. It glides rather than lunges. It hovers rather than charges. It appears not like a threat, but like a thought drifting through water. Do not let the softness fool you. The dumbo octopus is an efficient predator. Hunts small crustaceans, worms, and other seafloor creatures, lifting itself just above the sediment and descending with precise control. It does not need speed when surprise works better. It does not need aggression when patience is enough. Its whole style fits the deep. Quiet, economical, exact. In some ocean trenches and abyssal regions, dumbo octopuses are among the deepest living octopuses known, reaching depths where most cephalopods would never go. And there is something almost haunting about that. Octopuses already seem touched by another intelligence, as another design, logic. Their arms think with them, their skin responds like weather. Their eyes hold a kind of ancient watchfulness. To imagine such a creature hovering in the Mariana darkness, alone in black water above the deepest mud on Earth, is to feel that evolution has moods. Some creatures it shaped like tools, some like traps, some like whispers. The dumbo octopus is a whispers. Now the trench floor opens outward in your mind. You can begin to feel its scale. Not just a point, not just a number on a chart. A living region. A place where different bodies solve the same problem in different ways. How do you survive with little food? How do you move in crushing pressure? How do you reproduce in darkness? How do you sense what cannot be seen? That last question matters more than almost anything else. Sight at the bottom of the Mariana Trench is nearly useless unless you make your own light. Many trench animals do not. Eyes become smaller in some species. In others they remain, but serve limited roles. Different senses rise in importance. Smell, though in water it is really chemical detection, becomes critical. Touch matters, vibration matters, tiny disturbances matter. The water itself becomes a message board. A dead thing leaking molecules into the current. Living thing stepping through mud. A predator shifting its weight. A possible mate releasing signals too faint for us to notice, but impossible for another of its kind to miss. The deep trench world is full of messages no human ear has heard, and no unaided human body could ever sense. That is part of what makes this place feel supernatural, even though it is entirely real. Everything there obeys biology and chemistry and physics. Nothing breaks science. Yet the result feels like a hidden spell cast by pressure and time. The Mariana Trench is what happens when ordinary rules are pushed to extraordinary limits for millions of years. Life does not become magical, it becomes exact. And exactness, when carried far enough, begins to look like magic anyway. This is where many stories would be tempted to invent a giant shadow, a monster in the black, a mouth larger than reason. But the true wonder of the Mariana Trench is subtler than that, and in some ways more powerful. The trench does not need dragons, it already contains realities stranger than old sea legends. It contains shrimp-like scavengers that thrive beneath pressures that bend steel. It contains giant single cells living in mud that has never felt sunlight. It contains fish so soft that if brought up too quickly, they become damaged by the very absence of pressure. It contains animals that use chemistry as armour, patience as strategy, and darkness as shelter. And there is another revelation here, one that changes the emotional shape of the whole trench. The bottom is not beyond the reach of the human world. That may sound odd, after everything we have said about remoteness, but think carefully. The Mariana Trench is remote in depth, not in consequence. Human activity reaches it. Human chemicals reach it. Human waste reaches it. Plastic fragments and industrial pollutants have been detected even in the deepest ocean trenches. Tiny pieces, persistent compounds, molecules made in factories, and carried by currents and sinking particles into places that no human foot will ever stand. We like to imagine the bottom of the Mariana Trench as untouched, because untouched feels pure, and pure feels comforting. The truth is more painful. The trench is far away from us, yet not safe from us. That realization landed hard on the scientific world. To send a machine into the deepest place on Earth and find not only astonishing life, but traces of human pollution, is to understand something settling about our species. We are surface creatures, we build our cities in air, we live under weather and sunlight. Yet our fingerprints travel downward into the Haddle dark. We shape places we have never seen. We injure systems we barely understand. Mariana Trench keeps no perfect distance from human history. It receives what the whole planet sends. And still life continues there. Still amphipods feed. Still bacteria divide. Still sea cucumbers process the sediment grain by grain. Still the snailfish glides over the bottom in a soft-bodied confidence evolved over unthinkable time. There is dignity in that endurance, but there is also warning. The Haddle zone once seemed too harsh to matter to people except as a curiosity. Now we know better. Deep trenches store carbon. They bury organic matter. They host species found nowhere else. They preserve records of environmental change in layered sediments. They may contain biochemical solutions that help medicine, engineering, and our understanding of how life might survive on other worlds. If life can flourish under this much pressure, perhaps life, can flourish in the hidden oceans beneath the icy crust of Europa, or in buried water pockets on other planetary bodies. The Mariana Trench does not merely tell us about Earth. It stretches the imagination outward into the solar system. That is one of the great mid-story turns in this journey. We began with a hole in the ocean. We arrive at a laboratory for the universe, because the creatures at the bottom of the Mariana Trench are not just answers to one question. They are hints toward bigger questions. What is the true range of life? What conditions are really necessary? How far can adaptation go before it reaches a limit? And if there is a limit, found it yet? So far, the trench keeps answering in the same way. Deeper than you thought, stranger than you expected, more alive than you were ready for. Listen now to the quiet rhythm of that truth. Deeper than you thought, stranger than you expected, more alive than you were ready for. The repetition matters, because the ocean teaches by repetition. Wave after wave, tide after tide, snow of dead plankton, flake after flake, pressure inch after inch, evolution generation after generation. Nothing in the Mariana Trench happened quickly. Every body there is a long, slow sentence written by survival. Every adaptation is a word placed carefully by time. Take the snailfish again. At trench depths, ordinary fish face a chemical problem. Pressure interferes with the basic machinery inside cells. The proteins bend out of working shape. Membranes stiffen, nerves struggle. Yet huddle fish accumulate molecules that stabilize their inner systems, allowing their biology to keep functioning where ours would fail completely. That adaptation appears to have a limit. Researchers suspect that beyond a certain depth, even with all the chemical help available, fish may no longer be able to survive because the concentration required becomes too high to remain practical for living tissue. If that is true, it means the deepest fish live right near the edge of possibility. Think of that image. A small pale fish hovering at the border of what flesh can be, not in some fiery volcano or under an alien sky. Here, on Earth, in our ocean, at the bottom of the Mariana Trench, one species living close to a line biology may not be able to cross, and below or around that line, others continue where fish may stop. Amphipods, worms, microbes, giant single cells, maybe more still unseen. The trench is tiered not just by depth, but by what kind of life each depth allows. As pressure rises, the cast changes. Certain actors leave the stage, others enter. The play continues. That shifting cast becomes especially important when scientists lower baited cameras. The animals that arrive first tell you something. Fast scavengers suggest chemical sensitivity and mobility. Sediment feeders suggest a background of constant low-level nutrition. Rare visitors hovering just beyond the lights suggest caution, perhaps predation, perhaps curiosity. Sometimes a frame of footage contains enough information to redirect months of scientific thought. A body angle, feeding motion, a trail on the mud. The trench gives clues reluctantly, but it does give them. And often the clues come wrapped in beauty. Submersible lights sweep across the Hadal floor and reveal clouds of suspended particles glittering like dust in an attic, except the attic is 7 miles deep and older than human language. A dumbo octopus pulses upward from the sediment and vanishes into blackness, so smoothly it seems to be swallowed by the dark rather than entering it. Amphipods scatter and regroup in pale flashes at the edge of vision. sea cucumbers cast long, delicate shadows on the mud. Tracks cross tracks, tiny rises and hollows shape a landscape no storm ever touches. Host, it is one of the quietest places on Earth, and yet, the more carefully we look, the more action we find. This is an important lesson of the Mariana Trench. Silence is not absence. Darkness is not emptiness. Slowness is not stillness. Trench punishes shallow assumptions. That punishment can be gentle, but it is firm. Time we thought the Haddle Zone would be too harsh for complex life. It produced another surprise. Every time we guessed the food supply would be too sparse, cameras found animals feeding. Every time we imagined the bottom as a final graveyard, biology answered with movement. Movement. The Mariana Trench keeps correcting us, and in that correction there is humility. We are not the measure of livability. Our comfort is not the universal standard. Our kind of world is only one kind of world. There may be a child somewhere hearing this story who imagines the bottom of the Mariana Trench as a terrible place. And in one sense, for a human body it is. We cannot breathe there. We cannot tolerate the pressure. We cannot survive the cold, the dark, or the isolation. But for the creatures who belong there, aye. It is not terrible. It is ordinary. It is where food appears. It is where mates are found. It is where offspring begin. It is where generations pass uncounted by any clock we keep. The trench is not hell to its residents. It is home. That shift in perspective changes everything. Once you truly feel it, fear softens into wonder. The monsters become neighbours. The underworld becomes an ecosystem. The abyss stops being a blank and becomes an address. In that address, our daily routines, we barely understand. How often does a Haddle amphipod feed when no baited camera is present? How far can a dumbo octopus travel along the trench walls? What routes do snailfish follow between feeding grounds? How do trench organisms choose where to reproduce when the seafloor itself is shaped by landslides, quakes, and slow geological motion? Mariana region is tectonically active. Earthquakes can shake the trench, sediments can slump, terrain can change. Even in this quiet underworld, planet is still moving beneath the lives built upon it. So the creatures of the Mariana Trench do not just survive pressure, they survive change. There is a quiet resilience in that thought. The trench looks fixed from our perspective. A black endpoint on a map, but nothing on Earth is truly fixed. Not mountains, not coastlines, not ocean floors, not trenches. Deepest scar on the planet is still being shaped, and the life within it must adapt again and again. Slow. Change, yes, but real. Wall collapses somewhere in darkness. Sediment avalanches into a basin. Fresh mineral surfaces are exposed. Old feeding grounds are buried, new ones open. Bacteria colonize first. Small scavengers arrive. Larger animals follow. The underworld reorganizes itself. Process may be happening right now as these words move through the air above you. And still there are mysteries below the mud itself. Beneath the seafloor, deep in compacted sediments, microbes may persist in astonishingly sparse, slow communities, living on chemical energy over spans of time that challenge how we define activity. Some may divide only rarely. Some may maintain themselves near the edge of dormancy. Life down there stretches not only our sense of pressure tolerance but our sense of tempo. We are used to quick signs of living, movement, feeding, sound, growth we can watch. The Mariana Trench includes forms of of life operating on clocks so slow they feel geological. That slowness returns us to the feeling that has been building since part 1. The sense that the trench is not just a place but a myth, made factual, ancient, vast, only partly understood by science, yet entirely real. A place where every confirmed detail sounds invented until you read the data. Place where one cell can grow huge, where fish become nearly transparent, where shrimp relatives swarm in dark silence, where octopuses flap like small ghosts, where mountains could drown and still not reach the surface, and we have still not exhausted the wonder of the food chain here. Consider what happens when a large carcass reaches the trench floor. A dead squid, sinking fish, a piece of whale. The arrival is both accident and event. Chemical plumes spread through the water close to the bottom. Amphipods detect them. They come first, often in astonishing numbers. Their feeding tears tissue into smaller parts. Bacteria bloom across exposed surfaces. Worms and other scavengers take their share. What begins as one body becomes a cascade of nourishment, distributed through many mouths and many microbial colonies. In shallower seas, such falls are important. In the hurdle world, they may be transformative brief festivals in an economy of scarcity. For a while, darkness around the carcass is crowded. Then gradually it empties. The richest tissue is consumed. The swarm thins. Sediment takes back the remains. Bacteria continue the work where larger animals leave off. Bones may persist longer, offering hard surfaces in a world with few of them. Then even those surfaces fade into the background of mud and time. Nothing dramatic announces the end. Only quiet subtraction. That is another lesson of the Mariana Trench. Great events can happen without noise. A feast can appear and vanish without a single sound any human would hear. A life can begin and end 7 miles down, complete in itself, witnessed by no eye, recorded by no instrument, and still matter fully within the living system around it. This thought can make a person feel small, but it can also make a person feel relieved. The world is larger than our notice. Meaning is not dependent on an audience. Bottom of the Mariana Trench has been meaningful to itself for millions of years. As we move deeper into part 2, question rises with the pressure. If so many creatures live on the trench floor, what about the trench walls? What about the steep slopes dropping toward Challenger Deep? Are they lifeless cliffs of sediment and rock, or do they host their own hidden communities? The answer is that the walls matter. Water moving along them carries particles and oxygen. Their surfaces offer structure in a landscape, otherwise dominated by soft mud. Certain animals may use those contours as routes, refuges, feeding grounds. In some trench systems, steep terrain creates patches of different conditions over short distances. More current here, more sediment there. A slightly firmer patch, a small overhang, a fresh slide, exposing new material, port. In a world where little differences mean a great deal, topography becomes ecology. So, the Mariana Trench is not simply deep, it is varied. Even at these crushing depths, geography still shapes life. Imagine drifting in a submersible beside a Haddle wall. Your lights touch an angle of rock, fall into open black. Fine material slides occasionally from above like underwater dust. A pale shrimp-like form kicks away from the surface. Far below, your beams catch the floor as a faint grey plane. There is no horizon in the usual sense, only darkness thickening past the reach of the lights. And somewhere out there, beyond the illumination, something is moving with total indifference to your presence. That feeling may be the most honest emotional response to the trench. Terror, exactly. Not comfort, reverence. A sense of being allowed to witness a place that does not need you and never asked for you. Past. This is why the explorers who descend there often speak differently afterward. They describe not just the technical achievement, but the emotional force of the experience. The smallness of the vessel, the long descent, the absolute black. The realization that the lights reveal only a tiny circle of a vast hidden realm. Human beings are used to context, sky, ground, distance, weather, familiar scales. The Mariana Trench removes those anchors. It gives you only instrument readings, hull sounds, and the small certainty of your own light. Everything else is an unknown surrounding you in every direction. And still, even there, life appears, shape on the sediment. A burst of amphipods, a slow sea cucumber, a fish gliding just above the bottom. That appearance has a power difficult to describe. It is not just exciting. It is reassuring in a very deep way, as though the universe is whispering that emptiness is rarer than we fear. Given enough time, enough chemistry, enough persistence, something arrives. Something takes hold. Something learns how to live. There is one more turn we need to make before this part closes. The Mariana Trench is often spoken of as the deepest place on Earth, and that is true in a simple sense. But depth alone is not its whole identity. Its real identity is threshold. It is the border where many forms of life reach their limit, and new forms continue beyond them. It is the threshold where human engineering is pushed toward failure. The threshold where geology, chemistry, biology intertwine so tightly they feel like one process. The threshold where our ignorance becomes visible. At the start of this journey, question was, what lives at the very bottom of the Mariana Trench? By now, you know part of the answer. Amphipods live there. Sea cucumbers live there. Bacteria live there. Giant single-celled xenophyophores live there. Snailfish live near the deepest limits available to fish. Dumbo octopuses haunt nearby deep regions with a grace that feels borrowed from another reality. The bottom is alive, not with one famous beast, but with a community. A patient, hungry, chemically gifted, pressure-shaped community. But every good answer in the deep ocean generates a better question beneath it. How many species have we still not documented? How many lineages remain known only from a blur in the light or a fragment of tissue in a sampler? How many adaptations exist in the trench that we have not even guessed how to look for? Could there be forms so delicate that our sampling destroys them before we understand them? Could the mud itself hold genetic stories from creatures that rarely reveal themselves to cameras? Could the very bottom of Challenger Deep be less a final destination than a doorway into deeper layers of mystery? Because the mud is not just mud, it is an archive. It stores DNA, chemical traces, microscopic shells, pollutants, the record of what has fallen from above and what has lived below. Scientists are learning to read that archive more carefully every year. Bits of genetic material preserved in sediment and can reveal creatures that were present, even if the creatures themselves were never filmed. Trench may be telling us more than we have the language to hear yet. That is where part 2 must leave you. Not with closure. The Mariana Trench does not offer closure so easily. It offers evidence, then a shadow behind the evidence. It offers a creature, then the thought of another creature just beyond the light. It offers a measured depth, then a silence no measurement can soften. We have reached the point where the deep becomes intimate. The amphipods are no longer just data points. You can feel them swarming the bait in the dark. The sea cucumbers are no longer comic names. You can see their bodies drawing life from the mud. The dumbo octopus is no longer a cute image from a science article. It is a real hunter in black water, older than empires. Trench, floor is no longer a number. It is a plain of falling history and slow mouths. And yet beneath that plain, within that sediment, beyond the weak islands of human light, the Mariana Trench is still holding back its oldest stories. Mariana Trench has already taken everything familiar from you. And part 3 begins where the light of human courage meets the absolute weight of the deep. You are listening to Depth Unseen. Where light ends, the story begins. Tonight we go somewhere most humans will never go. Settle in, close your eyes, and drift with us. The Mariana Trench does not care about bravery. It does not reward it or punish it. It simply is what it is, crushing, freezing, lightless enormity that existed long before the concept of courage was invented, and will exist long after it is forgotten. And yet humans keep going back, keep building the machines, keep climbing inside the small steel spheres, keep descending mile after mile into the dark, not because the trench invites them, but because something in the human mind cannot resist the last great unknown on its own planet. Something in us leans toward the edges. Something in us needs to know what is at the bottom, even when the bottom could kill us without hesitation or malice. That need has a history. A long, strange, beautiful, and sometimes frightening history. Tonight, we follow it down. First serious attempts to measure the depth of the Mariana Trench came not from divers or submersibles, but from ships dragging weighted ropes through the water. In the late 1800s, the ocean floor was one of the great mysteries of the age. Scientists knew the ocean was deep, but how deep was a number nobody had reliably held in their hands. The rope-sounding method was slow and imprecise and exhausting. Miles of rope had to be lowered over the side of a ship. The weight felt for bottom contact, and then the whole length hauled back up again by hand. If the current moved the rope sideways, the measurement was wrong. If the rope snagged something on the way down, the measurement was wrong. The whole process had enormous room for error. But the numbers that came back from the Western Pacific were so extreme that even with all that error, scientists could not dismiss them. More than 4 miles, then more than 5, more than 6. The ocean in this region was not simply deep. It was impossibly, almost grotesquely deep. And when HMS Challenger returned to Britain in 1876, with its measurements from the Mariana region, the scientific world had to rebuild some of its basic assumptions about the shape of the planet. The ocean floor was not a gentle basin. In places it was a chasm, a wound reaching down into a darkness so profound that the word darkness barely covered it. That ship and its crew did not fully grasp what they had found. How could they? There were no cameras capable of going down there, were no machines built for those pressures. There was no biology yet to explain what might live in such a place. They had only numbers, and the numbers were so large they almost felt fictional. Almost. For nearly a century after Challenger, Trench sat in maps and textbooks as a measurement and very little else. Expeditions took new soundings and confirmed the depths. Technology improved. Echo sounding, which is the same basic principle as sonar, replaced rope and weight, bouncing sound waves off the seafloor and measuring how long they took to return. Ships could calculate depths with far greater accuracy, far faster, and without ever touching the bottom directly. Using these methods, scientists gradually traced the full shape of the Mariana Trench and confirmed the existence of Challenger Deep as the deepest surveyed point on Earth. But confirming a depth is not the same as going there. The first people to actually descend into Challenger Deep did not do it for science alone, though science was part of it. They did it because the question existed, and they were the kind of people who could not leave a question unanswered when the tools to answer it were finally within reach. Don Walsh was a US Navy lieutenant. Jacques Piccard was a Swiss oceanographer and the son of the man who designed the vessel they would use. Their craft, the Trieste, was a bathyscaphe, word meaning deep vessel in Greek, and it was unlike anything that had come before it. The float at the top of the Trieste was not filled with air. Air compresses under pressure, and at Haddle depths, air would be squeezed to almost nothing, removing all the buoyancy the vessel needed to descend and return. Instead, the float was filled with gasoline, tens of thousands of gallons of aviation gasoline. Gasoline is less compressible than water, which means it retains its volume under extreme pressure far better than air would. Hosts. It gave the Trieste enough buoyancy to hover and rise against the weight of the water. Ballast, made of iron pellets held around the outside of the hull, were released to allow the craft to ascend. Simple physics, extraordinary engineering. The crew compartment was a sphere of steel 7 feet in diameter. Inside that sphere, 2 men would spend almost 9 hours, descending for nearly 5 hours, on the bottom for 20 minutes, rising for over 3 hours, in a space roughly the size of a large closet, with no way to stand upright, with the sound of the hull adjusting to pressure for company. Absolute darkness outside the small porthole, broken only by their own lights. Walsh recalled later that the most frightening sound was not the creak of the hull, though the hull did creak and groan as the water pressed against it. The most frightening sound was the sharp crack that rang through the vessel when one of the outer plexiglass windows fractured partway through the descent. It sounded, he said, like a gunshot inside a metal room. They did not know what had cracked. They did not know how serious it was. They continued down. Down because turning back would have meant abandoning the last stretch of the descent after nearly 5 hours of work, because the inner observation window, the one that mattered most, was still intact. They reached the bottom. The lights of the Trieste touched the Haddle floor. Piccard looked out through his porthole and saw the creature he believed was a flatfish resting in the sediment, an animal in the deepest place on Earth, alive, resting. Unimpressed by the arrival of the first humans to ever witness this place, 20 minutes. Then the iron ballast was released, and the Trieste began the long, slow rise. When they surfaced, when they cracked open the hatch and felt actual air on their faces and saw actual light above them, Walsh later said, the dominant feeling was not triumph. It was relief. and then gradually disbelief. Not at what they had accomplished, but at what that creature in the mud had meant. That small pale shape on the bottom of the deepest trench in the world had quietly rewritten the rules. Life without limit, or rather life with limits so much wider than humans had drawn them that the old lines no longer applied. That lesson has been reinforced every decade since 1960. Every new expedition to the Mariana Trench has not only confirmed life at depth, but expanded its definition. Better cameras, better samplers, better genomic tools that can extract genetic information from a handful of sediment and reveal what lives there even without collecting a single visible creature. The tools improved and the picture grew richer, not simpler, richer. In the 1990s and 2000s, landers carrying baited traps began bringing up living amphipods from Haddle depths. Those amphipods were analysed, chemistry was studied, their adaptations mapped. The Timau story emerged, the chemical armour against pressure. New species were identified. The relationships between different trench populations began to be understood. It turned out that amphipods in the Mariana Trench share some ancestry with amphipods in other Pacific trenches, thousands of miles away. Pun, meaning that ocean currents had at some point carried ancestors between trenches, and that the Haddle Zone was not a collection of isolated pockets, but a connected, if very sparsely networked, community. The trenches talk to each other through the slow drift of ocean water, and the occasional survival of tiny larvae or fragments carried improbably far. That interconnection surprised scientists. The Haddle Zone is not a series of separate underworlds sealed from each other. It is a dispersed and loosely linked ecosystem, stretched across the deepest regions of every major ocean. The Mariana Trench is perhaps the most extreme version of that system, but it is part of a family of trenches, a family of deep, dark places, sharing species, sharing chemistry, sharing the strange evolutionary pressures that turn ordinary ocean animals into Haddle specialists. And within the Mariana Trench itself, within Challenger Deep specifically, the community is not uniform. Different areas of the trench bottom differ in sediment type, in how much marine snow arrives, in proximity to geological features. In some spots, the sediment is especially rich in organic material, and the bacteria counts are extraordinarily high. In others, the floor is rockier and harder, and different animals are more prominent. In some recordings, the number of amphipods arriving at bait is staggering. In others, the visitor count is more modest. The trench is not a single habitat. It is a mosaic of microhabitats, each favouring slightly different players. That complexity took time to appreciate, because for a long time we could only see what we put lights directly on. Think about what that means. Our entire knowledge of Challenger Deep has been built from visits so brief and so spatially limited that they would be like trying to understand New York City by shining a flashlight through a keyhole for a few minutes at a time. Flashlight reveals what is directly in front of it. A patch of pavement, a pair of shoes, a corner of a building. But the scale and the variety and the full life of the city remain unseen, unmarked, ongoing beyond the narrow cone of light. That is the honest state of our knowledge of the Mariana Trench bottom. We have seen patches, we have sampled fragments, we have inferred enormously from very little. And the inferences keep being right, which means the trench is more cooperative with science myths than its darkness suggests. But it also means the surprises are not finished. It means there are almost certainly things at the bottom of Challenger Deep that no camera has ever captured. Species with no names yet, behaviours never witnessed. Chemical strategies still unguessed, ecological relationships still invisible to us. One of the most telling moments in Mariana Trench science came not from what explorers found, but from what they found alongside the life. In 2019, the submersible DSV limiting factor descended to the bottom of Challenger Deep, carrying its pilot Victor Vescovo, became at that time the first person to reach the absolute deepest point of the ocean. His dive broke records for human depth, but the record was not the most talked about part of his descent. What was talked about was a piece of plastic. On the floor of Challenger Deep, the deepest point of the deepest trench in the world, cameras captured a plastic bag, a simple, ordinary plastic bag, the kind found in grocery stores and convenience stores, and kitchens the world over. It had made its way from the surface of the human world downward through 7 miles of water to the quad, to the place where geology and biology and pressure converged at their most extreme. And there it sat, in the lights of a record-breaking submersible, an artifact of civilization that had not even known the trench existed until a century and a half ago. It was a moment that required no comment from scientists to land with full weight. Vescovo also reported finding a candy wrapper and other synthetic materials on the bottom, not in trace amounts undetectable without laboratory equipment, visible there on the seafloor of Challenger Deep. Alongside that wrapper, the cameras caught, they always catch, when will they always catch, knärfligen, what at the bottom's movement, life, patient and unsentimental community of the Haddle floor, going about its business beside the debris of the surface world that had arrived, uninvited in their home. If the creatures there have any response to plastic bags, it is not visible to us. They do not flee from them. They do not investigate them with interest. They simply continue their existence alongside them. But, for scientists, the juxtaposition was impossible to ignore. Human chemical contamination, including persistent organic pollutants like PCBs and flame retardants, has been measured in the tissues of amphipods from the deepest trenches on Earth. These chemicals, invented and released into the environment by industry decades ago, sink into sediment and into the bodies of creatures that have no relationship to factories that produced them. The trench does not close its borders to the consequences of human decisions. The ocean is too connected for that. Everything that enters the water eventually sinks. And what sinks? Sinks to the bottom. And at the bottom, life is waiting, indifferent to what arrives, but not unaffected by it. That is the uncomfortable chapter in the Mariana Trench story that most wonder-focused accounts prefer to pass over quickly, but it belongs here. It belongs in the same story as the amphipods and the snailfish and the dumbo octopus, because the trench is not a museum piece. It is a living system in a living ocean on a living planet that includes us whether we visit it or not. And that knowledge adds a different kind of depth to the wonder. Not replacing it, sharpening it, to love the Mariana Trench, honestly, is to feel both astonished and responsible at the same time. Let us come back now to the descent. Let us ride with the explorers who went down after Walsh and Picard. Because the story of human visits to Challenger Deep is sparse in number, but enormous in implication. For over 50 years after the 1960 dive, no humans returned to the bottom of Challenger Deep. Unmanned instruments probed it. Data was collected remotely. But no person descended into that specific point again, until 2012, when filmmaker and explorer James Cameron climbed into a specially designed submersible called Deep Sea Challenger and made the solo dive. Cameron descended alone. Not because he had to, but because the vessel was built for a single occupant. The capsule was so narrow that he could not straighten his legs during the descent. He spent hours in the dark, watching instrument readings, listening to the sounds the hull made. He described the interior as less like a submarine and more like a cockpit built to survive something rather than to be comfortable in something. When he reached the bottom, he attempted to maneuver across the paddle floor to collect samples and film the environment. He reported seeing what he described as a flat, desolate lunar landscape with very little visible life during his observation time. Description caught people off guard. Where were the amphipods? Where were the sea cucumbers? Where was the life the science described? The answer is that the sea floor is enormous and life within it is not uniformly distributed. Camera showing you a small circle of mud may be in a quiet patch between feeding events. It may be between carcass falls. The absence of visible animals in a brief survey at one specific location does not mean the floor is empty. It means you are looking at a fragment of a vast place during a quiet moment. The science supporting Haddle life does not come from any single image. It comes from years of multiple expeditions, varied methods, accumulated evidence. Cameron himself was clear that the dive was not a final answer, but a beginning. A single window into a world that requires many windows. And then came Victor Vescovo. From 2018 to 2019, as part of the 5 Deeps expedition, Vescovo dove to the deepest point of all 5 of Earth's oceans. The Mariana Trench was last. His submersible DSV limiting factor, purpose-built for repeated extreme depth dives in a way previous vessels had never been. It could carry 2 people. It was certified for multiple deep dives rather than designed as a one-time achievement machine. It was built to return. During Vescovo's Challenger, deep dive scientists lowered landers separately to collect data and samples in different locations across the trench floor. The combination of a crewed submersible with pilot observation and uncrewed scientific landers working simultaneously gave researchers a richer picture than any previous single expedition had produced. They found snailfish, they confirmed amphipod populations, they measured sediment chemistry. They identified new features of the trench floor topography, and they found the plastic bag and the wrappers, both outcomes, the biological richness and the human pollution were real, and both were part of the same true story of what the Mariana Trench actually is in this specific moment in Earth's history. But perhaps the most scientifically important finding of the 5 Deeps era was not from any single dramatic image. It was from the genetic sequencing work done on sediment samples. Scientists extracted environmental DNA, which scientists call eDNA, from mud taken from the trench floor. This technique allows researchers to detect the presence of organisms purely from the genetic material they leave behind in their environment. Shed skin cells, metabolic waste, decaying tissue. All of it contains DNA that, preserved well enough in cold, stable sediment, can be identified. The results from Mariana Trench sediment samples revealed a community far more diverse than cameras had shown directly. Not just the large visible animals, but tiny nematodes, microscopic roundworms among the most abundant animals on Earth, whose hadal forms were barely characterized before. Foraminifera, single-celled organisms that build tiny shells and live in vast numbers in ocean sediment. Fungi, yes, fungi, metabolically active at hadal depths. In ways that still surprise researchers, the microbial communities were far more complex than the species lists generated by sampling and cameras alone could ever suggest. The bottom of the Mariana Trench is not a simple place. It is a complex community of visible animals, invisible microbes, genetic ghosts of transient visitors, and organisms too small or too rare to have been catalogued yet. And all of that life is happening right now, tonight. In the cold and dark and pressure, the bacteria are dividing, the amphipods are moving, the snailfish are gliding, the sediment is receiving its slow rain of falling matter. And the Mariana Trench continues its patient existence in absolute indifference to the sleeping world above it. Let your body sink a little further into that thought. The Mariana Trench does not know it is famous. It does not carry any awareness of the expeditions sent down to study it. The amphipods converging on a baited lander are not performing for the cameras. The sea cucumbers drawing patterns in the sediment are not leaving messages. Bacteria consuming organic particles are not aware of the scientists analysing their chemical signatures. Process in the hadal zone is pure biological function, undiluted by self-consciousness, untouched by narrative. Life happening, because life is what happens when the conditions allow it. And we are the only organisms in this story, perhaps in the universe, who know the story is a story. That is a strange kind of loneliness and a strange kind of privilege at the same time. To know the Mariana Trench is to carry 7 miles of dark water inside your understanding. To carry the weight of those pressures, those pale fish, swarming amphipods, those giant single cells living in the mud since before mammals existed. Once the trench is real to you, really real, and not just a number in a geography book, something shifts. The ocean is no longer a surface. It is a volume, deep and inhabited volume, most of which lives in permanent dark beyond any light you will ever make. The floor of the Mariana Trench is about 11 kilometers below the surface. 11 kilometers. Psst. If you drove a car in a straight line 11 kilometers, it would take perhaps 8 minutes. The drive would be ordinary. Traffic lights, perhaps, familiar streets. Nothing about 11 kilometers sounds impossible until you stack it vertically and pile the entire Pacific Ocean on top of it. That stacking is what the Mariana Trench is. Geography folded into a different orientation. Distance turned 90 degrees downward, and in that downward distance, every kilometre changes the nature of the world. The first kilometre changes the light. The second takes the warmth, taut. The third removes the last familiar biological communities. The fourth enters zones where the pressure begins to rewrite chemistry. 5th and 6th enter the abyss, the vast, flat, dark plains. The 7th and beyond enters the Haddle Zone, the Trench world, the realm named for the god of the dead, where life nonetheless persists. Each kilometre is a transformation. Each is its own lesson in what the planet can do with chemistry and time and pressure and darkness. And at the very bottom of all those kilometres, something is alive. Not despite the difficulty. Because of the solution, the difficulty demanded. That phrase will stay with us as we move toward the 4th part of this story. The trench is a difficulty, and life, over millions of years, found a solution to it. Not one solution, but many. Not one species, but a community. Not a temporary presence, but a permanent home. Not fragile visitors, but permanent citizens of the deepest address on Earth. The Mariana Trench holds its deepest secrets, not in the creatures we have found, but in the vast unmapped silence between every light we have ever lowered into it. And part 4 begins at the border of what science knows and what it honestly admits it does not. You are listening to Depth Unseen. Where light ends, the story begins. Tonight, we go somewhere most humans will never go. Settle in, close your eyes, and drift with us. The Mariana Trench has a patience that no human institution can match. Universities rise and fall. Research programs are funded and defunded. Expeditions are planned and cancelled and rescheduled, and sometimes lost entirely to weather or politics, or the quiet failure of a crucial component in a machine that cost millions of dollars to build. And through all of that, the trench continues. The amphipods feed. The bacteria divide. The marine snow falls. The cold holds everything at just barely above freezing. The pressure holds everything at 8 tons per square inch, and the darkness holds everything else. Patience is not a quality we typically assign to geography. Mountains do not wait. Deserts do not hope. But the Mariana Trench has a quality that feels like patience, because it has outlasted every attempt to fully understand it. Every expedition returns with answers that generate more questions. Every sample reveals a community broader than the one previously mapped. Every genetic analysis finds species no camera has captured. The trench gives up its secrets slowly, one fragment at a time. Each fragment is surrounded by a larger silence. That silence is tonight's subject, because the honest truth about the Mariana Trench is that we do not know most of it. We have not seen most of it. We have not sampled most of it. Our combined, direct human observation of the floor of Challenger Deep amounts to a handful of hours across a small number of dives spread over 6 decades. If you gathered every image ever captured at the very bottom of the Mariana Trench and played them together, they would not fill a full day of footage. They would not even come close. Deepest place on Earth has been witnessed by human eyes for less time than it takes to watch a long film, and yet from those fragments we have built an understanding. Imperfect, incomplete, but real, and that understanding keeps pointing in the same direction. Life, complexity, adaptation, community, not in spite of the extreme conditions, but woven so thoroughly through those conditions that creatures and their environment have become one continuous fact. What we do not know is whether the community we have glimpsed is representative of the whole, whether the species we have catalogued are the most abundant or merely the most detectable. Whether the behaviours we have filmed are typical or exceptional, whether the quiet patches of mud where some dives found little visible life were truly sparse or simply between events, whether the trench has daily or seasonal rhythms that no instrument has stayed down long enough to observe, because nothing has ever stayed down long enough. The longest any instrument has remained on the floor of the Mariana Trench is measured in days, not months, not years. The ocean is corrosive. The pressure stresses every material. The power supply runs out. The anchor releases on schedule, and the lander floats back to the surface, and the window of observation closes. What happens between lander visits is unknown. What the floor looks like between human expeditions, what predation events occur, what carcass falls arrive, what geological movements change the sediment surface, all of that unfolds unwatched in the dark. The Mariana Trench is one of the last truly unobserved places on Earth. There are wildlife cameras in Antarctic penguin colonies running year-round. There are continuous ocean monitoring buoys in the middle of the Pacific. There are satellites that photograph every square mile of the Earth's surface daily. But the floor of Challenger Deep has no permanent instrument, continuous record, no unbroken observation window. It exists in darkness between our visits, and continues its ancient business without a single instrument to capture it. What might we be missing? This is not a question asked in the spirit of mythology. It is not the kind of question that imagines sea serpents or ancient monsters coiled in the deepest mud. It is a scientific question asked in full seriousness by researchers who understand the scale of their own ignorance. The answer is that we may be missing a great deal. Consider size. The largest animals reliably documented in the deepest Hadal zone are relatively small by ocean standards. Amphipods, snailfish, sea cucumbers, none of these are enormous. The largest are perhaps the length of a forearm, but the Hadal zone is connected to the deep ocean, and the deep ocean contains animals of considerable size. Giant squid live in the deep ocean, not the trench, but their range extends into abyssal depths. Sperm whales dive to extraordinary depths in pursuit of food. The deep is not exclusively the domain of the small. Could something large exist in the Mariana Trench that our brief lit visits have simply never countered? It is not impossible. The trench floor is enormous, and our observation windows are tiny. A creature that moves slowly, stays near the walls, prefers specific sediment types away from where landers typically settle, simply inhabits the vast majority of the trench floor that no camera has ever touched, would be entirely invisible to the current record. This is not speculation offered to frighten. It is uncertainty offered honestly. The history of deep ocean biology is studded with discoveries of large animals that were theoretically present, but practically unknown for years or decades before being confirmed. The giant squid was considered a sea monster legend for centuries before its existence was proven by washed-up carcasses, and finally by direct photography in 2004. The megamouth shark, a very large and entirely harmless filter feeder, completely unknown to science until 1976, when one was accidentally caught by a US Navy ship off Hawaii. An entire species of large shark existing in the ocean for millions of years, unknown to science until the late 20th century. deep ocean keeps surprises like a library keeps books. Most of them are sitting quietly on shelves no one has yet pulled them from, and the Mariana Trench is the deepest library shelf. Scientists working on hadal biology are careful and methodical about this. They do not wave their hands at the darkness and say anything could be down there. They work from evidence and inference. But the inference, when honest, acknowledges enormous gaps. The trench has been sampled at a small number of points. The rest is interpolation. Rest is the reasonable assumption that what we found here is similar to what exists there. Sometimes that assumption holds. Sometimes it does not. One of the most important emerging frontiers in Mariana Trench science is precisely the technology of extended observation. New battery technologies and more durable technologies and durable materials are making it possible to design instruments that could theoretically remain on the hadal floor for months. Autonomous underwater vehicles that can move across the trench bottom under their own power, covering distances no tethered lander can reach. Acoustic systems that could create a continuous sound recorded from the trench floor, capturing movement, vibration, and biological activity over long stretches of time. The science is approaching a new era, one in which the Mariana Trench will be watched rather than merely visited, one in which the dark will finally have a witness with enough patience to match its own. But we are not there yet. Tonight we are still in the age of fragments. And in the age of fragments, the honest response to the Mariana Trench is wonder tinged with humility. Now let us follow a different thread. Let us follow a molecule. In 1970, a factory in a northern industrial city produces a batch of polychlorinated biphenyls, PCBs. These are synthetic chemical compounds used in electrical equipment, cooling systems, and a long list of industrial applications. They are extraordinarily stable. They do not break down easily in the environment. They persist for decades. They accumulate in fatty tissue. They move through food chains, concentrating as they pass from small organisms to larger ones. A process called biomagnification. By the time a PCB molecule moves from plankton to small fish to large fish to a top predator, its concentration can be millions of times higher than in the original source. In the 1970s and 1980s, PCBs were regulated and then banned in many countries because of their toxicity. But the molecules already released did not disappear. They entered soil. They entered water. They entered the ocean. They bonded to organic particles floating in the sea. And then, over years, particles sank, slowly, millimetre by millimetre, through the sunlit zone, through the twilight zone, through the midnight zone, through the abyss, through 7 miles of water, taking years to complete the journey. The organic particles carried their invisible chemical passengers downward. Eventually they settled on the floor of the Mariana Trench, and there the amphipods ate them. Researchers studying hadal amphipods from some of the deepest trenches on Earth, including trench systems in the Pacific, found PCB concentrations in their tissues at levels far exceeding those found in amphipods from far shallower and more heavily trafficked ocean regions. The deepest scavengers on the planet were carrying higher loads of banned industrial chemical than creatures living near the pollution sources at the surface. Because the trench is a sink, what enters the ocean eventually reaches the lowest point. What reaches the lowest point stays there, concentrated, archived, absorbed into the local food chain. The Mariana Trench does not just receive the biological rain from above. It receives the chemical history of human industry, decade by decade, layer by layer. The sediment at the bottom of Challenger Deep holds a chemical record of surface world decisions that were made by people who never thought about ocean trenches even once. That realization forces a reckoning. We did not choose to contaminate the Mariana Trench, but we did through ordinary daily industrial activity, through choices made about how to cool machines and insulate wires and treat agricultural fields. We loaded the ocean with molecule coil of hosts that found their way to the deepest place on Earth and entered the bodies of animals adapted over millions of years to a world that contained none of those molecules before. What effect does this have on Haddle life? Honestly, we do not fully know. The concentrations found in amphipods suggest significant exposure. But whether those concentrations reach levels that affect reproduction, behaviour, survival in Haddle species is still being studied. The animals continue to be present. They continue to be collected, continue to appear active and viable in the data. But the data does not go back far enough or deep enough to establish whether population, numbers, or community structures have shifted. There is no baseline from before the contamination to compare against. Trench was first sampled seriously after PCBs were already widespread in the global ocean. We arrived to study the trench after we had already changed it. That is a sentence worth sitting with. We arrived to study the trench after we had already changed it. And yet the trench persists. And yet the life persists. And yet the bacteria divide, and the amphipods feed. And the snailfish glides just above the mud, and the sea cucumbers draw their patient tracks across the sediment. The contamination is real. The persistence of life is also real. Both things are true at the same time, and neither cancels the other. This is the complexity that the Mariana Trench demands from anyone who wants to understand it honestly. It is not a pristine Eden below the reach of human consequence. It is not a ruined wasteland either. It is a severely pressured, extraordinarily ancient, biologically rich, chemically compromised, largely unexplored, persistently inhabited system that sits at the bottom of a planet we have been transforming without full understanding of the consequences. That description is not comfortable, but it is accurate, and accuracy is the deepest form of respect for a place like the Mariana Trench. Let us shift now from the uncomfortable to the extraordinary, because the trench is still full of wonder even inside its complexity. And tonight, before we begin the long, slow ascent toward the surface of this story, there is one more biological reality we need to visit. One that blurs everything we think about the boundaries of life in the most unexpected direction. Below the sediment floor of the Mariana Trench, through several meters of compacted mud and into the rock beneath, microbes persist in conditions that sound incompatible with any form of activity. Temperature is just above freezing. The pressure is crushing. The energy sources are almost undetectable. Yet, genetic analysis of cores, drilled through trench sediment, has found living microbial communities in the rock itself, not at the surface of the seafloor. These communities are called the deep biosphere. and they represent one of the most significant recent expansions of our understanding of where life exists on Earth. Deep biosphere is not unique to the Mariana Trench. It exists in rocks, beneath continents, and beneath ocean floors around the world. But in the saddle zone, combined with the extraordinary pressures of the water column above, the deep biosphere takes on additional significance. It means the living system of the Mariana Trench does not stop at the sediment surface. It continues downward into the rock, into a geological domain that most of us would never imagine as a place for biology. How deep does the deep biosphere go? That question is still being answered. Current evidence suggests microbes can be found in rock several kilometers below the seafloor, living on chemical energy from mineral reactions, dividing perhaps once every 1,000 years, maintaining a form of metabolism so slow it borders on the barely perceptible. They are not dormant. They are active, just active at a tempo we struggle to recognize as activity. If life exists in rock kilometers below the floor of the Mariana Trench, then the deepest place on Earth is not the bottom of the ocean. It is somewhere further down. Somewhere we have not yet built the tools to reach. Trench goes deeper than the trench. That idea should feel large. It should feel like the moment a map reveals a coast you had believed was the edge of the world, only to show more water beyond it. The boundaries of the living world keep extending. Every time science says, here is the limit, biology finds a way to be there on the other side. This is the pattern that the Mariana Trench teaches over and over again in every direction, downward past the light, downward past the pressure tolerance of most organisms, downward past the seafloor itself, downward into rock and chemical gradients and temperatures that vary only in tiny fractions, and still life, always still life. Now let the pressure ease a little. Not because we are ascending yet. We are not. We are still at the bottom, because the emotional weight of the trench is something that can be held more lightly when you understand what it truly is. It is not a void. It is not a symbol of death or erasure. It is a testimony, a long, patient, chemical, biological, geological testimony to the fact that life does not need an invitation. Life does not wait for optimal conditions. Life does not read the parameters and decide whether to attempt survival. Life simply does what life has always done. It finds the chemistry, uses it, it passes it forward. In the Mariana Trench, that process has been running uninterrupted for an inconceivable span of time. Trench itself formed perhaps 180 million years ago. The microbial communities that live in its deepest sediments may have lineages extending back millions of years, each generation handing off the chemistry to the next, in an unbroken line that began before humans, before mammals, before dinosaurs, before most of the complex life forms on the surface of this planet existed at all. The Hadal community is older than us by orders of magnitude. It will likely outlast us by similar margins. A host. There is something stabilizing in that thought, even though it should feel humbling. It means life on this planet is not fragile in the existential sense. Individual species fail, lineages end, climates shift, mass extinctions have happened 5 times in documented Earth history, and will likely happen again. But the fundamental biological processes, the microbial foundation, the chemistry of cell metabolism, The flow of energy from chemical bonds into living motion, these have not stopped for billions of years. They will not stop because a single species at the surface causes disruption, even severe disruption. Planet is more durable than its most powerful current inhabitant. The Mariana Trench, in its ancient, patient, pressured darkness, is evidence of that durability. It is a baseline, a reminder that life's range is wider than any single era of geology or any single civilization's impact can encompass. Take that thought with you as we begin the quieter section of tonight's story, because part 4 is also the part where the story turns inward slightly, where the facts that have been building become feelings, where the science becomes something you carry in your chest rather than just your mind. The Mariana Trench has given us so much tonight. Biology, history, chemistry, engineering, courage, contamination, mystery, the constant redrawing of lines that science had previously called final. And what it gives most quietly, most persistently, is perspective. 7 miles below a surface we call home, in conditions we could not survive for a single second without mechanical protection. The Sartica. In darkness that has never once been naturally broken by light, community of living things moves through its existence with complete and absolute normalcy. The amphipod does not know it lives in an extreme place, knows only the current, the chemical signal of food, the movement of a neighbour, the temperature it has always known. The snailfish does not consider its own improbability. It knows only the mud below and the open black water above and the slow drift of chemistry. That means a meal is somewhere nearby. They are not remarkable to themselves. Only to us. That is the gift the Mariana Trench offers quietly, in the dark. It offers us a chance to see how human our sense of the extraordinary is, how much of what we call miraculous is simply life doing what it always does. In a place we had not thought to look, how much of what we call emptiness is really just a space we have not illuminated yet. The deep does not need our wonder to be extraordinary, but our wonder needs the deep to stay honest. And the Mariana Trench, 7 miles down, in the cold and the pressure and the permanent night, still there, right now, tonight. In the same moment that you breathe, something at the bottom of Challenger Deep is also moving, also feeding, also carrying forward the ancient unbroken chain of life that connects your breathing body to the first chemistry that the ever organized itself into something capable of persisting. You and the amphipod at the bottom of the deepest trench in the world share something that nothing else in the known universe has been confirmed to share. You are both alive on the same planet at the same time. You are both built from the same basic chemistry. You are both part of the same story, even though you will never occupy the same geography, even though the conditions of your existence are so different, belong to different. They seem to belong to different worlds. They do not belong to different worlds. They belong to the same one. That is the deepest fact about the Mariana Trench. Not the depth, not the pressure, not the darkness, not the strange and extraordinary creatures. The deepest fact is that it is ours. It belongs to the same living world we belong to, part of the same unbroken biological narrative that includes everything from the first self-replicating molecule in a warm, shallow sea, 3.5 billion years ago, to the body breathing quietly right now in the dark above the story. The Mariana Trench is not foreign. It is the oldest part of home. And it is waiting, not for us specifically, not for our submersibles, or for our cameras, or our carefully lowered landers with their bait and their instruments. It was waiting before those things existed, and it will wait after they are gone. But tonight, in this story, in this long, slow descent, through facts and wonder and honest uncertainty, the trench has let us close. It has let us feel the weight of its water, the cold of its permanent night, the slow, patient movement of its creatures, the ancient chemistry of its mud, conch, and now the story begins to prepare for its final movement. Mariana Trench has given you everything it knows how to give. And now, in this final part of the journey, the only thing left to do is rise slowly back through 7 miles of dark water and carry what you have learned gently upward toward the light. You are listening to Depth Unseen. Where light ends, the story begins. Tonight we go somewhere most humans will never go. Settle in, close your eyes, and drift with us. The Mariana Trench does not say goodbye. It does not acknowledge departure any more than it acknowledged arrival. Forced, the water simply begins to release you. Layer by layer, the way a deep dream releases you in the slow minutes before waking, not all at once, not in a rush, but gradually, gently. Each fragment of the story rising a little closer to the surface until the weight that has been pressing against you from all sides begins, almost imperceptibly, to ease. We are ascending now. Not quickly. The body does not rush this. Mind does not rush this. After everything the trench has shown us, rushing would be wrong. Rushing would mean we had not truly understood. Because the most important lesson the Mariana Trench teaches is the one that cannot be hurried. Hot. The lesson that life at its most extreme is also life at its most patient. That the deepest things take the longest time. The most extraordinary truths reveal themselves only to those willing to wait in the dark long enough to see them. So, we rise slowly. As we rise, the story breathes out. Let us begin the ascent where we are, at the very bottom. At Challenger Deep, at 11 kilometers below the surface of the Pacific Ocean, where the pressure is 8 tons per square inch, and the temperature hovers just above freezing, and the darkness is the most complete darkness on this planet. Where right now, in this moment, you breathe. And the story moves through you. The amphipods are moving through the mud. The bacteria are dividing in the sediment. Snailfish is gliding just above the seafloor in its soft, translucent body, feeling the water with sensory organs tuned by millions of years to detect the faintest chemical whisper of a meal. This is where we leave our last anchor. We leave it here not as a marker of arrival, but as an acknowledgement of what exists. Something lives here. Something has always lived here. The bottom of the deepest place on Earth is not empty. It is inhabited. And that fact, simple as it sounds when stated plainly, is one of the most profound things science has ever confirmed about the nature of life on this planet. Changes the question. Not whether life can exist in extreme conditions. Life has proven beyond any reasonable doubt that it can. The question that remains, the one that will outlast all of us, is how far the definition of extreme can be stretched before life finally says no more. And every time that limit has been proposed, life has already been living past it. Xenophyophores in the sediment below you as we begin to rise. Those giant single cells 4 inches across, living in mud that has not seen light in millions of years. They are part of that answer. The answer they give is vast. The answer they give is quiet. The answer is written not in sound or motion, but in simple chemical persistence. I am here. I have always been here. I will be here after the curiosity that found me has moved on. There is a dignity in that. As we rise, passing through the lower Haddle sediments, the first thing that changes is almost nothing. The darkness remains. The cold remains. The pressure remains enormous, but somewhere in the quality of the water itself, in the fine suspended particles drifting upward past us in the opposite direction of our ascent, there's a faint sense of direction. Down is still down, up is still up, and up is, very slowly, towards something different from what we have known for the past 4 parts of this journey. The sea cucumbers below us now are still moving, still drawing their patient across the sediments, still processing the mud mouthful by mouthful, still converting the fallen remains of a distant surface world into motion and warmth and the continuation of their own ancient lineage. They do not watch us go. They have no mechanism for watching. They simply continue. That continuity is the Trench's final gift to us tonight, because what the Mariana Trench offers in its deepest and most honest essence is not spectacle. It is not the thrill of monsters or the shock of impossible depths. What it offers is continuity, the unbroken line of life reaching back through time so deep that the human mind genuinely cannot hold it. 3.5 billion years of biological persistence. 3.5 billion years of chemistry. Finding a way to persist, to replicate, to evolve, to fill every available space with something alive. The Trench is not the end of that line. It is one of the oldest sections of it, a section that has been running quietly in the dark while everything above it, changed beyond recognition again and again and again. That line connects you to this place. Right now, tonight, the carb in your body was once something else. A plant, an animal, a microbe in soil or ocean. The oxygen you breathe was released by photosynthesis from organisms that have been doing the same work since before the Trench existed. The water in your cells has cycled through the ocean and the atmosphere, and the land and the ocean again, in patterns that have been running since this planet had water. You are not separate from the Mariana Trench. You are made of the same materials, organised by the same fundamental chemistry, running the same ancient cellular processes that the bacteria at the bottom of Challenger Deep are running right now. The Trench and the person listening to this story are not strangers. They are expressions of the same planet, the same chemistry, the same impossible and ongoing experiment in biological persistence. When you understand that, really feel it, rather than just read it, the word abyss loses its terror. The deep stops being a threat and becomes a relative, something ancient and extreme and enduring that shares your most fundamental nature even while existing in conditions you could not survive for a moment. You are both alive on the same world. That is everything. We are passing now through the lower layers of the abyss zone as we ascend. 13,000 feet. 15,000. The pressure is still extraordinary, but begins to release its grip in increments, so small they could not be felt without instruments. The temperature remains near freezing. The darkness remains absolute. But the character of the water is subtly changing. concentration of suspended particles shifts. The chemistry of the water column changes in ways that organisms sensitive to such things can detect. Here in the middle layers of our ascent, the story of the Mariana Trench becomes the story of what the trench means to the people who have dedicated their lives to it. There are scientists who have spent 30 years studying hardle biology, researchers who have built careers on a handful of sediment samples and the genetic sequences extracted from them, biologists who have watched hours of lander footage looking for a body angle or a feeding motion that might reveal something new about how a species behaves. Chemists who have measured PCB concentrations in amphipod tissue and then sat quietly with the data for a long time before writing up the results. Engineers who have designed pressure vessels and calculated tolerances and worried for months about whether a seal would hold at depth, about whether the camera would survive, about whether the lander would release from its anchor and float back to the surface with all its data intact. These people do not descend into the Mariana Trench themselves in most cases. They work at the surface, on ships, in laboratories, in front of computers, piecing together the picture from fragments sent back from the dark. They are the interpreters of the trench, the ones who take its reluctant offerings and turn them into knowledge. And they speak about the trench the way people speak about something they love, with a mixture of deep familiarity and permanent awe. Because you can know a great deal about the Mariana Trench and still be astonished by it. Facts do not diminish the wonder. The understanding does not replace the mystery. The trench has enough depth, literally and otherwise, to hold both knowledge and unknowing side by side without contradiction. That is rare. Most mysteries collapse when examined closely. They turn out to be simpler than they appeared. The Mariana Trench does not collapse. The more you examine it, the more it expands. Every answered question opens onto a wider silence. Every confirmed species hints at undocumented neighbours. Every measured depth reveals another measurement still to be made. The trench is bottomless in its implications, even when its physical depth is known. That inexhaustibility is why it matters. Not just to scientists, to everyone who has ever stared up at the night sky and felt the particular sensation of being small in front of something incomprehensibly large. That sensation is not unique to astronomy. It is available right here, on this planet, in our own ocean, in a place that requires no telescope and no journey to another world. The universe of scale that the Mariana Trench offers is here. The incomprehensibility is here. The humbling is here. And alongside it, the wonder and the strange comfort of knowing that, in the most extreme place your planet made, life is present. Life persisted. Life found a way. We are passing 15,000 feet now. 18,000. The ascent is gradual and the changes are slow. This is not a journey that rushes. The ocean does not allow rushing. The story does not allow rushing. The only correct pace for understanding the Mariana Trench is the pace of marine snow. Slow, steady, falling without urgency, arriving exactly when it arrives. In the midnight zone now, 20,000 feet below the surface. Still dark, still cold, still full of creatures making their own light in the permanent night. The lanternfish with their rows of bioluminescent dots, the anglerfish with their glowing lures, The dragonfish trailing their lit barbels through the black water, all of them going about their existence in a darkness that has shaped them so completely that they are darkness made visible, dark water, given fins and eyes and hunger. These creatures do not know the story of the Mariana Trench. They do not know. They are part of a mystery that has captivated human attention for 150 years. They do not know. They live in a place that people will never be able to reach without machines built at great expense and great risk. They know only the water, the cold, the chemistry of hunger, the direction of movement, particular quality of bioluminescent light that means a possible meal or a possible predator or a possible mate. World is complete without our knowledge of it. And that is one of the most peaceful thoughts in all of natural history. The world does not depend on being understood to be fully real. That every creature in the Mariana Trench exists in total completeness, whether not a single human ever knew it was there. Their reality is not contingent on our curiosity. Our curiosity is fortunate to have found them. We are passing through 12,000 feet, 10,000. The twilight zone is approaching. Far above us, impossibly far, surface of the Pacific is lit by a sun that is either setting or rising or standing high, depending on the hour and the hemisphere and the particular moment of planetary rotation we happen to occupy. We do not know which. Down here, that information is irrelevant. The sun is not a factor in the story of the deep. It is a distant rumour, an abstraction, a concept that applies to another world, but we are heading toward it. The water around us as we ascend through 10,000 feet still holds the deep cold, the deep dark, the deep quiet. Something is changing at the edges of perception. The darkness is not less dark, but the quality of the silence is different. Host. There is something in the very faint upper distance that is not yet light, but is the memory of what light felt like before we left it behind. Frost. Let your body settle a little more into wherever you are lying or sitting. Let the weight of your limbs become something you notice. Let the rhythm of your breathing slow just another degree. The deepest part of the story has been told. The bottom has been visited. Creatures have been met. The science has been held, and the mystery has been acknowledged, and the connection between the deepest place on Earth and the living body breathing here tonight has been drawn as clearly as words can draw it. Now, the story asks only that you let it settle, like marine snow, like the slow drift of organic matter through 7 miles of water, like everything the ocean has been teaching without words since. Before there were words to learn from it. We are at 8,000 feet. Pressure is still far beyond anything the human body can tolerate without protection. But in the context of where we have been tonight, 8,000 feet feels almost like approaching air. The abyss has been our home for so long in this story that everything above it carries the quality of return. Here in the upper reaches of the Midnight Zone, the creatures are different from those we met at the bottom. Larger in some cases, more mobile, less adapted to the extreme chemistry of the Hadal Zone, and more adapted to the general conditions of the deep open ocean. Viper fish, gulper eels, vampire squid, which, despite the name, is neither a true squid nor a vampire, but an ancient creature in a category entirely its own, the sole living representative of its entire order of animals. A living fossil, swimming in the permanent dark. These animals are not trench specialists. They are deep ocean generalists, and in their own way, they are as extraordinary as anything we met at the bottom. But tonight, our attention belongs to what waits above them, and to what the whole journey means, in the quiet way that deep journeys mean things. 6,000 feet, 5,000. The light is still absent, but the cold has eased slightly. Not warmth, not yet, but the edge of cold has softened and enough that the body would notice the difference. If a body were here, flesh were making this ascent instead of imagination. The water is full of things now, in the way the deep water below was not. More particles, more organisms, more variety. The twilight zone is approaching with its clouds of lanternfish and its vertical migrators and its perpetual traffic of animals moving up into shallower water at night to feed and dropping back down into deeper water in the day to hide. The ocean is busier here. The commerce of predation and evasion and feeding fills the water in a way that the Haddle Zone does not. The Haddle Zone has its own commerce, but it is slow and spread thin. Here in the mid-waters the commerce is constant, drama of hunger playing out in 3 dimensions in the dark, every minute, every hour, day and night since the ocean formed and life first learned to swim. Been part of this ocean tonight in a way that is difficult to explain but easy to feel. The story has moved through you the way the deep current moves through water, slowly, invisibly, rearranging things at depth that do not change quickly on the surface. Something about the Mariana Trench, once it is truly received, does not leave the same way it arrived. It takes up residence somewhere quiet inside the understanding, and stays there, a piece of permanent knowledge about the range of the world. 3,000 feet, the twilight zone opens above us. The darkness is no longer uniform. There is something happening at the edges of vision now. Not light exactly, but the possibility of light. The architecture of a world that is transitioning, from permanent night toward the faintest approximation of day. Blue deepens from black in the way that winter mornings deepen before the sun arrives, too dark still to see, but no longer the same dark as full night. Here is where the journey asks its final question. Not a scientific question, not a question about species or pressures or chemical adaptations, a quieter question. The kind that surfaces in the long, still minutes before sleep, when the body has given up its work and the mind has given up its noise, and what remains is the actual quality of being alive in a world this large, and this strange, and this persistently surprising. The question is simply this. Given everything the Mariana Trench has shown us tonight, given the amphipods in the dark and the snailfish at the border of biological possibility, and the giant single cells living in ancient mud, and the bacteria dividing in rock below the seafloor, and the plastic bag sitting on the floor of Challenger Deep, and the PCBs in the bodies of creatures that never asked for them, and the 20 minutes Walsh and Pickard spent at the bottom in 1960. And the way Pickard's hand trembled slightly when he wrote about the creature he saw in the sediment. Given all of that, what kind of planet do we actually live on, Boast? The answer the Mariana Trench gives is not simple. It is not clean or comfortable or easily summarized. We live on a planet where life is so determined that it fills the space between rock layers 7 miles below the surface of the deepest ocean. We live on a planet where a fish can be soft and pale and become translucent and survive where steel would be crushed. We live on a planet where a single cell can grow to 4 inches in the dark without anyone to witness it. Host. We live on a planet where the deepest wound in the seafloor is full of creatures that have been living there since before the earliest humans drew the first marks on cave walls. And we live on a planet where a plastic bag from a grocery store can travel from a street to a landfill to a river to the ocean to the bottom of Challenger Deep in a span of years. Where molecules invented in factories become permanent residents of the bodies of the pressure-adapted animals in the world. Where the most extreme and remote environment on Earth is still not beyond the reach of what we do at the surface. Both of those things are equally true. The planet is astonishing. The planet is also fragile in specific ways that matter. Not fragile in its fundamental biological persistence, which is nearly indestructible, fragile in the specific communities and species and ecological relationships that have taken millions of years to build. The amphipod at the bottom of the Mariana Trench is not in danger of being replaced by something better adapted to PCBs in some near future. It is in a slower, more ambiguous kind of danger. The kind that does not announce itself. Kind that builds in the background until the absence is noticed. And by then, the absence has been there for longer than anyone realized. But tonight that wait is not the last thing. Tonight, the last thing is the light. 2,000 feet. 1,000. The blue is real now, not imagined. Not the memory of blue, but actual blue, actual light, penetrating from the surface of the Pacific above us in long, wavering columns that, from below, like a cathedral, like a Foster and Son. Made of water and sun. The temperature rises slightly. The pressure eases towards something the body could tolerate. Creatures here are the ones familiar. From nature documentaries. From aquariums. From the edges of reefs. From the shallow sea just past a beach. World is becoming recognizable. The Mariana Trench is 7 miles below us now. All of it. The Haddle floor. With its slow mouths, and its ancient sediment, and its bacterial cities, and its snailfish, and its impossible xenophyophores, and its unobserved and unrecorded hours between our visits. All of it is still there right now, in the dark below the dark below the dark, Honst. It does not go away because we have ascended. It does not stop because the story is ending. The trench persists, as it has always persisted, in its own deep time, in its own deep chemistry, in its own ancient and patient existence. And somewhere above you now, very close now, is the surface. Let the light come to you gently. Let the warmth find you, the way sunlight finds the surface of the ocean, spreading outward from a single point, a coast, a single point, reaching further with each passing moment, turning the cold blue water, gradually, incrementally, towards something that could be called golden. Let the darkness hold you for one more moment. Before the light, the darkness is not empty. You know that now. The darkness is full of things you cannot see, full of lives you cannot visit, full of biological processes running, on clocks so slow they feel geological, and on scales so small. They require machines built for the purpose, just to detect. The darkness is the majority of the living world. The light we stand in is the minority. The creatures in the sun are the exception. Creatures in the dark are the deep and ancient rule. You have been in the rule tonight. you have visited the majority of the planet's biological territory, which is cold and dark and pressured and ancient and filled with life adapted to conditions that make our comfortable surface world look like a brief and exceptional accident of geology. That perspective does not make the surface less beautiful. If anything, it makes it more so. Because the surface, with its weather and its warmth and its colours and its loud, busy commerce of sunlit life, precious, not because it is typical, but because it is rare. Not many planets have this. Not many places in this solar system have this. The surface of this world, with its blue sky and its changing seasons and its light that reaches 12,000 meters down before giving out, is extraordinary. And the trench, in its impossible dark patience, is the thing that makes the surface comprehensible by contrast. You cannot know how high a mountain is without a valley to measure from. The Mariana Trench is the valley from which everything else can be properly measured. 500 feet, 200. The surface is very close now. The light is full and real, and the water is the colour of blue glass held up to the sun. Schools of fish move through the beams in loose formations. A sea turtle passes in the middle distance unhurried, ancient in its own way. The surface above is a rippling silver ceiling, alive with the movement of wind and wave. We are almost home. But before we break the surface, take one last moment here, suspended between the deep world and the light world. In the place where the pressure has eased, the temperature has risen, and the familiar organisms of the shallower sea move through water that sunlight can actually reach. Think of the snailfish at the bottom of the Mariana Trench. Small, pale, soft-bodied fish hovering just above the Haddle floor. That fish that holds the record for the deepest living vertebrate ever firmed on Earth. That fish that carries tamao in its tissues to protect its proteins from pressure that would unmake ours in a fraction of a second. That fish that glides through the coldest, darkest, most pressured environment on this planet. With the complete, unremarkable normalcy of any creature, in any environment going about the business of staying alive. That fish is alive right now. At this moment, as the light reaches you from above, and the story completes its long arc from the surface to the bottom and back, the snailfish is in the dark, moving, tasting the water with its sensory organs, following the faint chemical gradient toward a possible meal, living its ordinary, extraordinary life in the deepest place on Earth, in absolute indifference to everything happening above it, connected to everything happening above it by chemistry and history, and the long, unbroken thread of life that ties all living things to all other living things across all the years, and all the depths, and all the light, and all the dark of this planet. That connection is real. It is not metaphor, it is chemistry. It is ancestry. It is the fact of life being one continuous process expressed in many forms across every environment this world has to offer, from the warmest surface coral reef to the coldest Haddle floor. You are part of that process. You always have been. Surface breaks around us now. The light is full. The air is real. The sound of the ocean is the sound of the world breathing as it has breathed, since water first gathered in the low places of a cooling planet, and life first stirred in the chemistry of those early seas, beneath you as you float on the surface of the Pacific. 7 miles down, the Mariana Trench continues. It will continue tomorrow, day after, and the decade after, and the century after. Long after the submersibles that visited it have been displayed in museums. Long after the scientists who studied it have passed their knowledge to students who will purchase it onward again. Long after the ships that sailed above it have been replaced by technologies we cannot yet imagine. The trench will be there. The amphipods will be feeding. The bacterias will be feeding. The bacteria will be dividing. The snailfish will be gliding. The marine snow will be falling. The sediment will be receiving everything the surface world sends down, including our chemistry, including our plastics, including our questions, including the carbon breath of every living thing above it. The Mariana Trench will hold all of it, as it has always held all of it. In the dark, the cold, in the pressure, in the ancient patient silence of the deepest place on earth. Let the darkness hold you now. Let the weight of what you have learned settle into you, like sediment, settling into still water, slowly, completely, coming to rest in the quiet places inside you where the biggest things live. There is nothing left to find tonight. Only stillness, only the sound of your own breathing, only the gentle recognition that you are alive on a planet wilder and deeper and more persistently extraordinary than any single story can fully tell. The story is ending. The trench is not. Somewhere below in the dark, something is alive. It has always been alive. And now, gently, let the ocean hold you. Let the darkness you have travelled through become the darkness that surrounds. Sleep, soft and full, and inhabited by nothing that means you harm. You have been to the bottom of the world tonight. Come back carrying something true. Let that be enough. Let the water be still around you. Let the pressure ease from every part of you that has been holding tension. Let the cold release and the warmth come. Let the current take you nowhere in particular, slowly, without urgency, in the general direction of morning. The Mariana Trench is behind you now, 7 miles deep. In the permanent dark, the story continues without you. And that is exactly as it should be.